So just that you know, I will tell you in the chat when you go live. I will type there you're live now. Okay.
Jacob. Monique.
Yes.
Over to you, we're live.
So should I go ahead, Brendan, or?
Yes, go ahead.
You prefer to introduce me? Okay.
So welcome everyone to the session that we have today as part of the Big Data Value Forum, which is going to explore edge computing, the convergence point in the human cloud continuum framework. We're delighted to open with our colleague Monique, who's coordinator of the EU IoT CSA, is going to provide a bit of context before we hand over to our panel discussion, before later exploring some of the opportunities to join in with the NG-IoT initiative with the projects Assist IoT and IoT Engine. Over to you, Monique.
Thank you very much. Good morning, everyone. And now I should be able to share my screen. Coming in a second. So here we go. I hope you're all doing fine, despite the situation is becoming crazy once again for all of us. So we would very much prefer to be all together in the same place, but we are virtually here to share a few thoughts about edge computing and the convergence point in the human cloud continuum framework. I hope you can see my slide in the right modality, meaning in the presenters. Okay, great. Thank you, Federico. So I'm the coordinator of the European project EU IoT that is at work to build a strong European IoT and edge ecosystem. There are 5 partners running these projects: Fortis, BlueSpecs, Martel Innovate, Intrasoft International, and Aarhus University. The challenge and the approach somehow is to ensure that we create a strong ecosystem that is linking all the major stakeholders, communities, and initiatives in the area of Internet of Things in Europe. And the idea is very much to make sure that all the various players in the value chain creation for Internet of Things and their application in a variety of sectors allows to engage all the players. In fact, one of the key aspects is that IoT and Edge see really much the convergence of different technologies. And this is why there are several players and communities that are traditionally separated. So we try to avoid segmentation, we try to link them together, but we also try to close the gap between the demand and the supply, matching market pull factors with the technology push aspects. And also one of the main priorities is to ensure that also the smaller players, especially those that create the tissue of the European economy, that is the vast majority is SMEs, can engage into this ecosystem and benefit of the various resources that are available. Now, there are some key aspects that are of high relevance for all the European players in the IoT edge space. And they are becoming even more important in a forward-looking perspective, looking also at how Horizon Europe is pushing for the situation to evolve. First of all, openness. Openness is one of the core value, but also one of the characteristic traits of the European efforts that are pushing for open source, open data, open standards, and open hardware. This is very much a field that is allowing innovation to be nurtured and to grow beyond individual projects' boundaries. We also try to work and harmonize across efforts that are not necessarily IoT centric. There are a lot of efforts that come from the cloud computing community, but also from the AI, from the 5G and beyond 5G. So the key idea is really to connect all of them. And another key aspect is that it's essential also to reconsider how we need not only an intelligence, but also a resilient infrastructure. The COVID situation has shown how much we depend on digital means for accessing also very essential services. And this is why there is a convergence of aspects that do not only relate to technology, but they relate to business, they relate to education, they relate to societal inclusion. Now, this is the, the desiderata. How do we get there? How do we get to a connected ecosystem that overcomes complexity? Well, we need to, first of all, take into account that there is quite of a number of complexity factors. And they are dictated by some emergency situation that we are all living now. But it's also related to some key aspect that is, first of all, the transition from the Horizon 2020 framework program to a new program, the Horizon Europe, that started beginning of this year, but of course that has incurred several delays due to the pandemic. There are also a number of projects in the community which have pushing priorities in possibly several directions. And there are communities, initiatives, not only at the research level, but also at the industrial innovation level, like AIoTI, Artemisia, BDBA, ADRA, and you name it. But also an increasing prominence of efforts in standardization and open source communities like Eclipse, Etsy, Fiverr, and so on and so forth that are working across this community. Now, to bring them all together, I tell you, it's not an easy task, and it's not necessarily what we want, but we need to link them. We need to listen to all the various aspects in order to really create a roadmap for European efforts to become relevant and impactful. So what we are doing in the EU IoT project, and today we are going to talk about a number of those aspects together with our invited experts, is to try to connect the dots and create the foundation of this strong, vibrant EU IoT ecosystem, in which there are several different facets we are investigating from a technical point of view in the transition that goes from the human to the let's say core of the network, the cloud services. So there are human interfaces, there are devices involved, there are gateways, access networks, there are the big cloud computing infrastructures, and there is, last but not least, the necessity to serve these data spaces that are becoming so much of a central aspect in our digital transformation. Because in fact, all of this infrastructure from the human to the cloud allows to exchange data and allows to elaborate data that provides value and services to the user. And with the edge, of course, this transition is pushing for data value creation more towards where the data is created, more towards where the users and the consumers are. We have produced a couple of white papers, deliverables within our project, and in the last few days, on the 29th of October, we published a new version of this deliverable. You can find it there, and you can also provide comments. I put here the URL for the page where you can find it. Just go to the NGIoT.eu website, and in the news, you will find it as the first news. Now, today, we're going to try to explore a few aspects that, together with the EU IoT project, we tried to capture. So, as I mentioned before, we see this transition from, human cloud continuum going through several, let's say, research and innovation areas. One concerns human and IoT interfaces. One concerns the far edge. Then we have the near edge that is closer to the infrastructure. Then we have the let's say, networking data infrastructure. And finally, we have the data spaces. We have identified together with experts and various consulted advisors what are the main priorities, what are the main key aspects that need further investigation. And today we will discuss some of them with our invited speakers. What is clear is that there is an increasing push for intelligence at the edge. There is an increasing push for decentralization because architectures need to be multi-access and more flexible to different use cases, different needs, but also different devices and network interfaces. And also there is more and more the necessity to create context-dependent IoT edge platforms, because of course, not only in the use cases there is diversity, but there is diversity also on the boundary conditions at policy, regulation, legal level, depending on the various also vertical market segments where these technologies are deployed. Clearly, there are some important aspects that you can see here, some pull factors that are of high relevance. First of all, we need low power and reduced traffic. We need reduced latency for real-time decisions. We need to ensure privacy and security, especially if you think that, a lot of these use cases concern really access to healthcare services and education. So really essential aspects of our everyday life. And then we need, of course, efficiency in terms of costs and sustainability. We need these devices to be green and to help us greening the environment. Now, this is challenging. This is why we're working together with other players for this next generation IoT initiative and context to grow. We need collaboration. We need to unify ecosystems and networks to deliver value. We need intelligence across the board, from tiny machine learnings to high performance computing. So intelligence is everywhere, must be everywhere. We need to support open source and open standards, defining what are the major mechanisms to allow interoperability of different devices and different technologies. But we also need to foster new skills and new, let's say, specialists to be able to bring everyone on board. Nobody should be left behind. And and last but not least, we need to make sure that this transition, this digital transition, is green by design. Not easy. We're at work on this, and today in the next session, which will be moderated by Tania Suarez from BlueSpecs, we will hear in more details what the community is doing from different perspectives. So I pass now the floor to Tania for follow-up discussions.
Thank you very much, Monique. That was incredible scene setting for our conversation. Now, maybe just a couple of things before I introduce my colleagues on the panel. I think that first of all, please don't anyone be put off by the word deliverable. This is Eurospeak, but in the reports that Monique referred to, there's an incredible wealth of information. So I really do suggest that you look at those, and please do get back to us with any comments that can push thinking to the next stage and can really help us get this to a stage of deployment and awareness and of use that is valuable, not just the business, but the society. And possibly just another pointer there, actually, the Data Act, and I think this is something that I'd like to ask also the panelists about, that's going to be a really interesting backdrop for many of the things that we're going to be discussing and exploring in the next panel. So this next panel is called Dancing on the Edge, Accessing New Value from Data on the Edge. And with me, I'm very happy to welcome Christian Winkler from Siemens, Federica Facca from hCloud, and Mirko Presa from Aarhus University. They're all colleagues of ours. We are all part of the same ecosystem, and we are really happy to be able to be together once again and to explore some of the cutting edge issues around edge computing and data use and where it's going to be adding more value. Before we ask the questions that are going to help us explore these issues in greater detail, I would like to invite each of my colleagues to just give a very brief presentation on who they are, what their role is, and what they could feel they can contribute to the panel. So Christian, if I could perhaps start with you, please.
Okay, so thank you very much for the intro. My name is Chris Winkler. I'm with Siemens Corporate Technology, which is, so to say, the central R&D department of Siemens. And there I have the position of a senior principal expert in IoT. My background actually is electrical engineering. I hold a PhD in communication technology. And before I joined corporate technology, I had various positions in Siemens business units, mainly in the area of communication technology. As you may remember, Siemens was active in this game quite some years ago. Currently, I'm also active, besides being in the expert group of this endeavor here, in the IPSAI-SYS, so this economic subsidy program on the cloud edge continuum. And this, what I see there is certainly also impacting the way I'm looking into the edge discussion that we have today. So a little bit on maybe background on what I think about edge, if this is now the appropriate time to elaborate a little bit on that. Siemens, as you know, or is this not the right time, Tanya?
No, please do go ahead, and then we'll pass on to Federico. So please do.
Okay. So Siemens is, as you know, an OT player. So we are active in various domains like discrete manufacturing, process industry, smart buildings, smart grid, mobility, rolling stock. So more or less everything that you would see as the basis infrastructure for many businesses. And in all of our domains, the digital enablement is, so to say, the very key topic for new business models, optimized processes, and also environment protection tasks. And the interesting thing is that in all of our domains, we now see edge computing as a very central element of the game. But, and that's where it becomes complex, the architectures, the underlying architectures are quite different. So some are more cloud-centric, some with a strong on-premise focus, some are highly distributed, like smart grid or the rail examples. Some have reliable connectivity to run the edge connectivity to the cloud, for example. Some only intermittent, like on rolling stock, where you only from time to time have connectivity. Some are cost sensitive, and that's why probably there's no one size fits all edge stack or edge architecture from the device edge to the cloud edge that really covers all the use cases in the same way. Or let's put it in other words, the usefulness and potential applications of near edge and far edge varies a lot depending on the specific use cases and domains. By the way, we also have a little bit a different definition on far edge, but I think we're going to touch that later compared to the picture that we saw in the intro. What we at least see as a common denominator for all is that all make use of on-premise edges. So the on-prem.
I think we just lost Chris.
Yeah, I was just wondering whether it was me. Perhaps if we take this opportunity
Chris
is he?
Yeah.
Chris?
Okay, no.
Hi,
it's fine.
Chris.
I think you want to hand over, right?
Yes, exactly. And I think that you just dropped off there, but we can pick up on some of the things perhaps that you were just
Yeah, that's
discussing
fine.
there in just a second. So yeah, just to introduce perhaps some of the other panelists before delving deeper into some of the issues that you very nicely framed there in your introduction. Federico, would you like to introduce yourself and very briefly tell us what your
sure.
experience is and what you, thank you.
My name is Federico, and I'm working as CTO at Martel Innovate, and at the time being, I'm also coordinating Edge Cloud, CSA, in the field of cloud computing, and of course there we are looking at the same topics as UIoT, but from the perspective of the cloud computing projects and a research agenda. And of course, it's interesting to see how this is converging somehow on different aspects from the point of view, especially of the application domains. And I leave to Mirko.
Yes, Mirko, may I ask you to introduce yourself, please?
Yeah, thank you, Tanya, and thank you, Chris and Federico, as well as Monique, for setting the scene already. So I'm an associate professor at Aarhus University at the Faculty of Business and Social Sciences, and I work in a specific department that overlaps engineering and business. Actually, we are called Business Development and Technology. We work a lot with Siemens Gamesa, for instance. We have a big factory out there, as well as Vestas is around the corner as well, of course. So we work a lot with manufacturing companies, and my specific interest in the area is actually to combine, various digital technologies with manufacturing. So we work on blockchain, IoT, on distributed architectures, for instance, towards compliance-based systems and so on. So I have a particular interest myself in working on these topics from an application perspective, but my main focus at the department is actually working with digitalization and business models. And in particular, we're looking at IoT and business models there. And this is also the relationship that I have into this context, which is I'm also a member of the team of the EU-IoT or NG-IoT context where Monique is coordinating, and I'm together with Tanya and Brandon and Federico and so on, working on the various deliverables that you mentioned, Tanya. So, and I'm looking forward to talking a bit further. I think, Chris, you've mentioned a lot of really interesting stuff that I want to pick up on. So
let's kick off the conversation, because I think Chris was one of the things, and I think it was just before he dropped off, said that actually there's no one size fits all, and the usefulness of computing really varies greatly across the far and near edge. So perhaps for the uninitiated, could we start with how you see, or where you see, the far edge and the near edge, and where those boundaries actually are? We've heard also the concept of the fuzzy edge. Is it a thing, or is it just something that appears in somebody's blog and then somebody it just gets repeated? Maybe, Chris, if we can come back to you and you can start with your views on that, please. Maybe Chris has dropped off. Mirko, perhaps if you can, yeah. Oh, Chris, you're there. Okay.
I think the web client sometimes does a few naughty things.
Very badly, Chris.
It could also be the reason that Germany is now all working from home again. It's a bandwidth issue.
Okay, Chris, we'll try one more time, and if not, we can ask maybe Mirko to. There we go. Chris has muted himself. Mirko, perhaps if you can answer that question, and we'll come back to Chris when he has better connectivity.
So, I mean, about the definition, definitions along the line of now where we are in the edge cloud continuum and what that specifically is, I think makes sense in contexts like standardization more than, let's say, for people that are now developing applications. I think eventually we will crystallize the definitions out more and more as industry is picking up the technology more and more, and we can see solutions emerging. So I think one of the issues that we'll probably talk about later on as well now is that, IoT is complex, but we kind of solve the cloud-centric way of making IoT applications work. So this is something that Edge is edging against or moving against somehow, trying to challenge. But I don't think we need to argue about definitions per se. But I would still like to hear Chris's version of his far edge definition, of course, to see if we're missing some sort of set of requirements that some nuances that we see in the requirements or the uses of edge. Because if we don't have it as a solution, we have it as a concept. We need to use language to elaborate on it.
Absolutely. Chris, I'll just ask you to unmute when you feel that you can connect more or less stably. In the interim, Federico, would you like to jump in on the question?
Yeah, I mean, of course, I agree with Mirko. I mean, spending time on saying what is far edge or near edge, it's probably not a good way of using our time, because the truth is that there is no agreement at the moment. There is not going to be us, the one who bring up the agreement, but it's more likely that in-stone definition will come from standardization bodies, as Mirko said. Of course, it is very true that you have a different perspective from the different industrial actors. Clearly, the telco thinks edge in some terms. In the industrial IoT, the edge is seen as another term, and this also means what does it mean to be far edge or near edge. In my personal view, yeah.
Federico, I just want to be really opportunistic, and I can actually see Chris now.
Yeah,
so I'm going to ask him to come in. So Chris, we were talking about, you mentioned that the usefulness varies across the far and near edge. And we'd like you to maybe expand a little bit on that. Mirko was saying, and Federico was agreeing, that actually technical definitions between what sits where are perhaps not so necessary other than for standardization initiatives, but for practitioners, really, there's no need to define where the far edge or the near edge start and end. But from a practitioner perspective, and somebody who's absolutely working in this in the coalface, what have you seen? Is this a relevant distinction? Because you've already said that the usefulness can vary.
Yeah. So what is clear, at least from our perspective, is that one demarcation line is certainly the question on-premise, off-premise. And from our point of view, it is now not so important, while taking aside some technical aspects, which I can come back to in a minute, whether this is now a near edge that we are talking to outside the premise, a far edge, a regional edge, or a cloud. But of course, the closer the edge compute capability is to the premise, the more likely it is that you find stable connectivity and you are able to provide some real-time capability. And so this is for us more the difference, whether you can really cover industrial grade quality with your edge compute capability. This is the more important question compared to whether it's a regional, a far, or whatsoever edge. For the ease of our discussion, we tend to stick to the definition that we also use in the IPSAI, which is a 5-level specification, starting with a device as an edge capability, an on-prem edge, and then the demarcation line to the public sector comes the far edge, the near edge, the regional edge, and the cloud. And to me personally, this 5+1 level seems to be somehow reflecting the fact that we already heard we have many players in this cloud edge game who also all have their sweet spot and want to establish interesting business cases. And I think the summation of all those ideas is now this complex architecture. So I'm not really sure whether this is really backed completely by at least the industrial use cases that we see today.
That's
that's why I think.
Go ahead.
Okay.
So Mirko, I think that was QU because Chris really referred there to the business case attached to, the on-prem, off-prem, which is kind of like more of an IT old school distinction, but he actually related that to the ability to have industrial grade connectivity and to be able to get that data to your point of operations when you actually need it. So do you want to weigh in on that?
Yeah, I think there's a sort of a clear case for moving processing towards the edge for actually two very conflicting reasons. One is, Chris mentioned rolling stock, you don't have connectivity all the time. So you actually have to have some intelligence on the systems to manage things either autonomously or locally, at least for a period of time. Whereas the other one is the direct opposite. You have connectivity all the time because you're on premise, but you can't offload the processing to the cloud because that's just too far away physically. Speed of light is limited. So 300 kilometers if you want 1 millisecond delay in responses, that's the physical limit. So there are two very different arguments why you would want to do this. But then when we get to the specific applications, then those need to be very specific requirements to drive those. And I think blanketing that for a specific sector or a specific purpose, that's difficult. And this is why you will have, again, like we had at the beginning of IoT, this very complex mess of actors saying, well, far edge, near edge, no, you can solve it with the cloud. And there will be many business arguments for what you will choose in the end.
Thank you, Federico. Bringing in your experience, I think, there with hCloud, how are you seeing that distinction and the relevance for different industrial sectors or even ecosystems? Because, of course, it's not just about manufacturing. It's about the supply chains as well. It's about the ecosystems in which many businesses operate.
Yeah. It's clear that, as was already mentioned, each actor in the ecosystem try to position itself and to be sure that he has a central role in this new continuum between the device up to the cloud. And but I think that this is more the view really of who is providing the technology. In the end, the central point of the understanding is who is using the technology and what are the needs he has to realize a given solution. And my fear is that in this sense there is still a lot to be done to really come up to meet this requirement and needs, because in the end, what we are witnessing, and from different, let's say, direction, from the network, from the IoT, from the cloud technology, what we are seeing is different attempt to adapt and evolve technologies that are there to meet these new requirements. But of course, it's like when Tim Berners-Lee was asked if he would design the web the same way today as he designed it more than 20 years ago. And the answer, of course, will be no. Yeah. So if you need really to start today, probably thinking at this scenario, you will develop totally different technologies to be matching, appropriating this application scenario. But the reality is that you have a number of technologies that are there, and you need to interpret with, and you need to integrate in the solution you are delivering. And this means that the only way to go for that is an evolutionary approach today. And really, one of the major challenges is, for example, we're talking about moving the processing in a continuous way between the edge and the cloud. But the truth is that the device you have in the cloud or in the edge are totally different. Especially when you talk about IoT devices, and clearly as of today, and maybe in the future it will be different, you don't have a a piece of code that you move from the cloud to the edge and works perfectly. Really the hardware architecture are completely different, and this is a big challenge if you want to move the computation in the continuing, in the seamless way. And clearly, then there are many other challenges as well. This is not the only one. I mean, we have problems with the what is happening at the network level. We are now used to have a network as a sort of commodity, but in this new computing continuum scenario, I mean, you might want to have a commodity maybe with different characteristics from the point of view of the network, which today you have totally not control over in the continuum framework, and the same things also for energy aspect and so on. So clearly, this is, I think, there are a number of elements that will need still to be addressed, and probably moving from cloud native edge computing, which is more or less the current approach to defining what means to be edge native in this context.
Thanks, Federico. So I just want to bring back Chris on the point, because you were saying that we're seeing different architectures, and we're seeing these again, in the NG-IoT program that we're running with Mirko. But Chris, you specifically mentioned that. Federico's saying that that's actually a problem for deploying and for really scaling, I suppose, the adoption of the edge across industries. Is that also what you're seeing within Siemens and your clients?
Yeah, actually, but I would shed maybe a little light on a completely different aspect of the adoption, which is not the question of which architecture I'm talking about. It's the fact that it was mentioned before that the small medium enterprises are the very core of our economy. But at least in our experience, many of these small medium enterprises are not really the experts in IT. So you cannot talk about complex architectures. We need to help them to get the first step into their digital journey. And that means, for me, all the discussion around edge and edge cloud continuum and all that stuff always needs to keep in mind who are we addressing. So it's, in our case, it's OT folks. So we need to make sure that these solutions work plug and play, can be operated and installed by these kind of people. And our experience is, at least for the SMEs, the first thing to do is provide them with some digital compute capabilities, for example, an on-premise edge or something, and start providing value. And then you can start extending the architecture to something more complex, where you talk about moving around workloads between different types of edges and all that stuff. So I think the solutions we come up with also in the IoT domain may never lose the view on the ease of use and the way how to install it, to operate it, to automate all these processes and all that stuff. And I think for the application, this is even more important compared to the question whether it's near or far or whatsoever edge.
No, and just to pick up on something you've said there, and perhaps on the second part of the name of the panel, which is about accessing new value from data on the edge. You've specifically referred to that as the driver for SME adoption. They have to see where the value is. I just had some data come back from PitchBook, and in the first 3 quarters of this year, AI exits have topped $166 billion, which is more than 3 times the total of 2020. And many of the applications, or many of the investments, are in actually platforms that enable that very easy identification of data or integration of data, and then the use of that data. Mirko, maybe can I ask you about that in a little bit more detail? Why don't we have an advantage in this area? Because that you could say, oh, we have a great ecosystem. We have companies that are world leaders in many industrial spheres. But if you look at the AI exits, the biggest ones are in fact from the US or even from China. what can we do to really make sure that we're at the cutting edge of providing these very easy tools for SMEs, but also for large companies to use?
Yeah, I think I don't think we are. If we take the measuring stick on the investments, yes, clearly there is a problem. We're not competitive on that. I think when we're looking at the level of innovation, the topics that we're addressing, and the smaller companies that are actually offering services, in particular on data integration, I mean, I see it in Denmark a lot, that they're very interesting companies that are doing very interesting legacy-based work, but also I recently talked to a company that, well, I'm not going to go into detail, but they do some novel data integration across, sectors that haven't been very digitally focused, but they are very business oriented to make to not go for that large scale before they're actually making a business. They're making good businesses from the start. So I think there's an imbalance in how money is accessed, or the ambition of the company that they have, probably. But from a technological perspective, from an innovation perspective, I don't think that we are outclassed or anything. I think it's maybe the ambition, the way that you're trying to approach it, that has a big problem. What I'm immensely positive about, or optimistic about, let's say, is that with the current developments, I think companies like Siemens now as an example, Chris being on the call, but Bosch or Grundfos, or some of the companies that are providing infrastructure assets in particular, they're shifting towards the services. They're shifting towards integrating digital technologies and IT, including AI, into their products. Now, if they do this with partners or do that themselves, that is, that depends on the organization and the maturity. But I think it's an encouraging sort of development that I think we'll see in the future also pick up to work well in Europe's favor, let's say.
Thank you. Chris, would you like to come in, or Federico, do you have any comments on that?
Yeah, I have a couple of comments. I think clearly, I mean, I totally agree with Mirko on the fact that in Europe we have, from the point of potential in terms of innovation and technology, we have a lot of assets that we should exploit. Clearly, compared to China or US, we have other problems. And one problem is the size of the market, because despite we claim to have a single European market, compared to what it means having a single European market in US or in China, is not the same, because there are still barriers from a point of legislation, especially. And clearly, for a company, this means that accessing a wide market in Europe, which needs to comprise a multitude of countries, is much more complex than trying to enter in the market in US and then boom, you access the whole market, because you don't have many of the limitations that you have in Europe. And on the other side, I have also to say that the way companies, and here I'm not much referring to the SMEs, but large companies do innovation in the US is quite different than the way large companies do innovation in Europe. And this is clearly, if you look at who are the leading contributors in the key open source projects that are defining our digital infrastructure today. So if you look at the key contributors in OpenStack, you will see they are from China and from US. If you look at the key contributors in Kubernetes, you will see that they are from China and from US. And this is the true also for most of the key open source projects, even in the artificial intelligence. And I mean, I have the feeling that there is a sort of fear of putting the hands in these projects, but the truth is that in the end you end up, as most of large companies in Europe are anyhow in the sector are using these tools, but they are not contributing to them, and this means that then they are leading the way these projects go ahead, and probably we need to change this perspective.
Thank you, Federico. I'm now going to turn to some of the questions that have been posed through the chat. So the first one is from Rigo Vanning. So thank you, Rigo, for participating actively. I have a question about the data formats that are used to get interoperability from the edge to the cloud. Do you need specific things, or will JSON or JSON LD just do the trick? Who'd like to take that?
Well, it's always hard to reason on whether this is really complete. But what I see is, since we are also active in the W3C Web of Things group, we are actually heading it. We see that JSON LD as a basis seems to be quite appropriate to address many of the interoperability issues. So at least from that point of view, I would say yes, with JSON LD you can do probably a lot, or maybe even everything.
Yeah, I think it depends also what you mean by edge, because of course the IoT device will it will be difficult that it talks JSON, LD, and so on. You will have probably more lower level data format at that level, and then surfacing, lifting them more appropriately to some more intermediary edge elements.
Do you mean because the number of devices is just by nature going to be so different?
But
that
even because JSON LD is, of course, naturally meant for a RESTful communication payload, and efficient IoT level communication is not done using RESTful communication. So you use MQTT or MQP or LoRa and other things, and of course you can probably even somehow encode inside there JSON, but then the payload size will be big, and then is not efficient, and efficiency is important at that level. So clearly,
but I think
yeah.
May I briefly comment on that?
Yeah,
I think that it is a difference whether you use formats like JSON LD just to describe the data format, and the true payload communication is then done in a separate way. And this is the approach that we take in Web of Things, that you do not do all the communication, the IoT communication in JSON LD format, but to describe how the format looks like, even proprietary or other standards like OPC and so on. This description is done in JSON LD. And I think this split somehow makes a lot of sense.
Thanks, Chris. That's enriched the point, I think, a little bit more. So Ken Foster says that we lack early growth stage venture capital, bridging the grants from the EU and growth stage capital. And Rigo says the data market services was a nice project trying to connect startups with the right accelerators. Do you have any further discussions or points perhaps on that ability to scale the technical knowledge that we have and the industrial infrastructure that we already have available, and to make sure that we have a next generation of companies that can be born from that, and the new opportunities, including business opportunities that arise from this new metaverse? Mirko, perhaps that's a question to you.
I'm really sorry, Tanya, but you just dropped out for a second. Can you?
Oh, okay. No, never mind. I'll pick up another question here. So Rigo says he has a discussion with Dave Raggett from W3C3. Do we need a standard from SCADA payload to JSON LD? These are very technical questions, so I'm hoping that you can answer that. I don't know if that's perhaps again to Chris.
Actually, I don't know. I simply
Okay.
don't know. So I have no real answer for that. What we try to, what we try to push is that knowing that we will never converge on one standard for data formats and for description of interfaces and all that stuff, we acknowledge that we will have this heterogeneity and are looking for ways to bridge them. And this is again the way that we are pushing this Web of Things activity. And personally, I think this is more meaningful because we have separate types of standards in separate domains, like in building, like in industries, for good reasons. So they are designed for that, and they will stay there for quite some time. So our job from IoT's perspective is really more to build bridges between them, not to replace them.
Thank you. And on that point of building bridges rather than replacing them, I'd like to hand over now to the next colleagues, who are Ignacio Lacalle Úbeda from the University of the Polytechnical University of Valencia, who is going to be presenting Assist IoT, and after him, Artemis Volkidis from Synexlis, who is going to be telling us about the open calls in IoT Engine. Over to you. Thank you.
Thank you. Thank you.
Sorry, and before, sorry, I'm really sorry. Before I pass on, I forgot to thank my panelists. That's a huge faux pas. So, Christian, Federico, Mirko, thank you so much for sharing your insights. And apologies for not having done that sooner. I'm looking forward to continuing the discussion in the expert groups. Thank you very much, everyone. Sorry about that, Ignacio.
Okay, no worry. Thank you, Tanya, for the kind presentation, and also congratulations for the whole session, and thanks to the panelists before. The conversations for today are very interesting and actually quite to the point to the presentation I'm going to make, because actually I'm about to present one of the projects in the ICT56 cluster of projects that it's related with these edge IoT computation architectures that are being proposed at this point from projects since late 2020. And in fact, I'm going to present the open calls that we are launching for companies to try to get some funding for continue this paradigm. So I will try to be very short, as I don't have much time. In a nutshell, I am representing Assist IoT, that stands for Architecture for Scalable Self, Human-Centric, Intelligent, Secure, and Tactile, Next Generation IoT, which is a research and innovation action and started late 2020 and would finalize in 2023. Represented by 15 partners and will be validated in 3 pilots in 3 different verticals: in maritime ports, in smart safety of workers in construction sites, and in the automotive sector with cohesive vehicle monitoring use cases, centering on the field domains of the edge computing, smart networking, and human centricity. To be very short of our main goals, we have proposed and are actually now developing and will be implementing an architecture based on different horizontal and vertical enablers, drawing directly from the recommendations from IoT and Create IoT 3D layer architecture. And we are aiming at introducing this advanced context awareness or distributed data protection, privacy, orchestration in different layers of our architecture, willing to demonstrate it in 3 different pilots that will be performed during next year and 2023. The main ambitions we have, and we are expecting to contribute to the state of the art, and as it has been outlined before by Mirko and the other panelists, we are focused on what actually the main points of evolution as we see them in the sector, meaning multiple streams of human-centric IoT, AI-infused applications, AI in the edge, scalability, flexibility, allowing to get smarter, more secure environments for the next generation of the Internet of Things. The goals are similar to the rest of projects in our cluster, and we are continuously discussing together about what we are doing in that regards. What I would like to present today mainly is to invite you all the audience hearing me at this moment, to come join us through the first round of open calls we are launching in the project. When we were funded by European Commission, we were granted 900,000 euros to be distributed in 2 rounds of open calls. The first one that has been opened in the 1st November last month will fund 7 proposals applying for 60,000 euros each, applying for a maximum duration of 9 months, and we are willing to fund innovative proposals tackling some challenges related to the next generation IoT, focused on one out of our 3 pilots. Okay, there are some, let's say, indications of what these challenges consist of that can be either pretty specific for the use cases we have envisioned, or either broader for contributing to the paradigm global of our architectural proposal. I guess this presentation will be shared to you afterwards, but so you will be able to check specifically these details. But for your information, we will be funding individual actions, no consortiums, and mainly SMEs or university research centers, meaning no large companies. The participation will need to be contextualized, as I have said, to one of our pilots, contribute to our paradigm, and you will be joining our consortium since next year. What must be done, or what can be done for applying for this open course? Well, present a proposal of 15 pages. Any details on the preparations are able to be consulted in our webpage in the guide for applicants, and you must submit one form, and you will be evaluated by external experts based on this criteria of the relevance, impact, excellence, and say stickiness to our pilots and our architecture. And globally, say the timeline is the following. We will be closing, as I have said, the open call is open since November. It will close on 28th February next year. So we invite you all to come in and come along and present your proposals. And afterwards that, 2 months of evaluation will be followed by the announcement of the winning proposals that will finally join our project about June or July, summer next year. Finally, these are some relevant links that you can consult. Feel free to contact directly me or any of the people that are indicated in the contact in the webpage. You have any question, don't hesitate to ask, and you are invited to come along and present your proposals. We expect you there. Thank you.
Thank you very much, Nacho. So hopefully you'll be seeing some applications from those of you checking in with us this morning. May I now invite Artemis to take the stage and to share your presentation whenever you're ready. Perfect. Artemis, we can see it there.
So thank you very much. Can you see my screen right now?
At the moment it's blank, or at least it is for me.
Blank?
There we go. That's it. It's reloaded. Perfect.
Better, right?
Thank you. That's
Excellent.
perfect. Thank you.
So thank you very much for having us here and for the interesting discussions that were held. My name is Artemis Voulkidis. I work for Synergy Solution, and I act as a technical manager for the IoT Engine project. Now, before I present the open call opportunities that we offer as a project, a brief introduction. We're a big consortium of 19 partners covering 8 countries. We started off sometime in 2020, so October 2020. We just passed the first year, and the duration is 36 months. So we do have a couple of years in front of us. Now, if I was to describe the IoT Engine vision in just one slide, I would present this one. So our work is actually targeting the entire layered architecture of IoT, let's say, landscape, starting out from the component layer and up to the business layer, featuring advances in all the intermediate layers. And we do that having some principles that we value by design. Mostly we focus on interoperability, security and privacy, traceability, and data sovereignty by design. Now, having said that, the core technologies that we are developing, they can be found on this slide on the left side. So we're working on the communication side with edge cloud connectivity and dynamic resources management and discoverability. We are having very good progress in offering a machine learning as a service framework that is able to run across the continuum of edge fog cloud, which is very, very interesting for us. And it can also have support related to privacy preserving federated learning, for example, and technologies like those. We are having support for augmented reality systems and the augmented reality based control, and several considerations regarding cybersecurity. We have 4 living labs and 10 use cases, and they pertain to smart cities, smart agriculture, Industry 4, and smart energy. Now, having said that, we are having all these activities as a project, but we would like to expand. So this is why we are launching 2 open calls. The first one is already up and running, as you can see in this slide. The deadline is due end of this month, so 30th of December. And the winners, they are going to be announced later in 2022, and they're going to be integrated into the project as partners, so accessing the entire range of IoT engine technologies and the foreground knowledge that we produce by the end of March. So 30th of March 2022, we expect to be a bigger consortium. And then for those of you that you cannot join during this first open call, there will be a second round in July 2022. Still, this would last again for 3 months. So end of October 2022, the submission will end. And by December 2022, we will have some more partners entering the consortium until the September 2023 that the project is due to end. Now, a few more details about the first open call. So we expect to have a total number of 5 winners. The budget per applicant is up to 150,000 euros. So the total budget for this first round of open calls is up to 750,000 euros, which is quite, let's say, big. The scope that we're interested in at this point is open interfaces and access to new IoT systems and access to edge acceleration services, for example, via embedded software and FPGA software developments. The evaluation criteria that we have, they are related to the concept and innovation, technology, impact, and the applicant team. So it's more or less generic, as you can find in all relevant open calls. And you can find more information on our website and on F6S. So we are funding all this, we are running all this funding process through F6S. So make sure to visit our site and follow us on our social networks so that you can find more information. Thank you very much. That's it.
Thank you very much, Artemis. That was very clear, and again, hopefully we'll get some interest in the calls, really offering some new insights and technologies that can make this a reality across multiple domains. So, Brendan, I think we've reached the end of the session. From my part, to thank Monique for the very helpful introduction and scene setting, panelists, Chris, Federico, and Mirko. Looking forward to continuing to work with you, and Brendan and the team generally, Catherine, who's been doing the moderation and the toing and throwing from the different platforms to make sure that we got the questions there. Monique, did you want to say any final words there?
I just wanted to say that it was a very dense and interesting discussion. I hope everyone has been able to follow. We'll publish a short report out of this event on the NGIoT.eu pages, so please stay tuned. And thanks a lot, Tanya, and our speakers, but also Brendan and the other colleagues that have been helping to organize this session.
Absolutely. Thank you very much and have a good day. Bye-bye.
Bye.
Bye.
Okay, then I think we're ready to start. It's still good morning. Many thanks for being able to present this talk on cognitive digital twin pipelines in the trans continuum, which is related to experiences in various domains, the process industry, also manufacturing, but in particular also now digital twin of the earth for agriculture and other domains. What we see here, I'll come back to, is digital twin toolbox from the Cognitwin process industry project. I'll change to, let's see, the next slide here. Okay. Let's make sure this works. Okay, it jumped a bit. Now it works. Okay, here's my bio. There will be some slides that I will not talk about all of the details, so they will be for further reference. But I will put this in the context of what we have done on the big data value reference architecture and different domains dealing with architectural elements, and have that in the context of cognitive digital twins. So this is the title and the context of the talk. And I will talk about that also related to architecture and the transcontinuum and to data spaces for various domains. This is actually a kind of precursor to the upcoming full session we have on Friday, the 3rd, from 1530 to 1700 on data-driven intelligent digital twins, where we will revisit this together with a number of presenters and for a panel discussion. One of the motivations underlying this is that there is a lot of domains that now are working with digital twins. SINTEF is a large multidisciplinary institute, and here are some of the activities we have on digital twins in the area of manufacturing, where things have started both discrete but also continuous manufacturing with process plants, but also building and construction and smart cities, environment and climate, autonomous vessels, the energy sector, both oil and gas and renewables, also agri-food, aquaculture, fishery, agriculture, health and biotech. From the SINTEF Digital Institute, we are supporting all of these areas with digital twin technologies. And one of the interesting, say, challenges, I would say, is that there is also a lot of different technology standards initiatives related to maybe domain-specific approaches here. I think that one of the driving forces has been on Industry 4.0 and the platform industry 4.0, and as we'll hear in later sessions, also on technologies such as AAS, the Asset Administration Shell, and further promotion of this through organizations like the Industrial Digital Twin Association, but also linked to data spaces, the Gaia X perspective. But then there are additional initiatives such as the Industrial Internet Consortium, which looks into digital twin interoperability, which is an issue, and the Digital Twin Consortium that has a foundation in the digital twin definition language and others. Also interesting to note that in ISO SC41 on IoT and digital twin has now been established, and we participate there. So this is like a placeholder for digital twins in ISO, strongly connected to ISO 42 on AI and big data, which is supporting this from an analytics AI machine learning perspective and also a big data perspective. But one of the first standards in digital twin is from ISO TC 184 on industrial data, ISO 23247 digital twin manufacturing framework. But we see also other things emerging, such as from TC10 and the standard 81346 on industrial systems, installations, and equipment, where work has been going on with the information management framework for this. And also long history in building and construction with TC59 and ISO building information modeling. And if you look into this, there are somewhat parallel tracks that are not harmonized with each other, suggesting challenges of interoperability here. Also new initiatives such as the UK National Digital Twin has introduced another information management framework for digital twins. And then we have the aspects of spatial-temporal or geospatial digital twins from ISO TC211 and the Open Geodata Consortium. And currently, all of these initiatives are less interoperable, less harmonized. So we are looking into what will be commonalities and differences for the future. We're driving it a little bit from the process industry and manufacturing, where I think a lot of this originated, working now with a special issue of a journal on cognitive digital twins with Liliana Stojanovic from Fraunhofer and myself. And there are still some opportunities to join in for extensions of this, where we are looking into here, particularly the process industry, but we will also follow this up with other areas. There has also been an article already looking into different digital twin representation technologies. Some of these standards that was mentioned, but also open source. I think within a lot of the projects we have, we are using AAS as a core technology, but it's a continuous relationship to look at what are the synergies and differences with the others, such as the DTDL and the NGSI LD and other aspects. What can we find of interoperability and on synergies? So this will be one of the further activities. I'll start out with our experiences from the process industry and the relationships to that, where we have established a digital twin toolbox. We're also harmonizing this with 5 other projects. There is a series now, or a set of 6 projects that are all dealing with cognitive plans and are using different variations of cognitive twins. We will hear some of these further presented also on the sessions on Friday. And we are looking at synergies in this area as well as with others. Coming back to the BDVA reference model, this is still a good anchoring point because all of the areas here are relevant when we talk about cognitive digital twins. We have the underlying say transcontinuum of the infrastructure, we have the data management, we have the analytics, we have the visualization and control. And we see that this apply in all of these different domains, which covers everything that BDVA has been focusing on, more or less. And there are actually few areas where there is not current activities on the digital twin. Another perspective that we have been found quite useful is what we see in the middle here of a kind of life cycle, going from data acquisition to data preparation to analytics to action and interaction, monitoring and control and visualization. This maps well into the reference model. It also maps well into the areas of the ADRA framework on AI with sensing and perception, knowledge and learning, reasoning and decision making, and action and interaction. All of these areas are relevant in an operational digital twin. And we have refined this into digital twins, as we'll see here, talking about digital twin data acquisition and collection, digital twin data representation, digital twin models, both hybrid and cognitive analytics models, and digital twin visualization and control and interaction. As we have a foundation in manufacturing and we have many presentations of that, I'll also focus on another area on destination Earth and a digital twin of the ocean, where we will have some slightly different perspectives, and that will be an example I will also introduce later. Note also that this life cycle perspective is harmonized with emerging standards such as the ISO SE42 AI standard, where we see that collection, preparation, analytics, and visualizations are element of this standard. Further also on the ISO SE42 work on machine learning, where we have data acquisition, pre-processing, modeling, model deployment, and operation. So we find this life cycle perspective on digital twin, which also suggests the pipeline underlying structure as a common framework. So in the Cognitwin project, we have established tool components, reusable components in all of these areas, dealing with the IoT side, sensor data and actuator data to the left, communication, orchestration and pipeline connection with the connection of stream pipes and other pipelines technologies, storage handling, event processing, various digital twin representation and data spaces, machine learning together with physics-based models, visualization, interaction, and control. And what we are looking for is evolution of this toolbox to be able to support applications in different process industry domains, but eventually also other domains. So in a pipeline context, we also have a new project called Data Cloud, which looks into a big data pipeline in a computing continuum. And with the computing continuum, we mean basically the continuum from the IoT, the sensor and actuators, to the fog, to the cloud, with HPC and supercomputing, and feedback to the edge and the mobile context, and all of the activities that takes place in this pipeline. So these pipelines can be merged in terms of technology support for a digital twin pipeline. This is again from the Data Cloud project that is working now on how to extract data from different sources and how to establish the pipeline, how to simulate and execute the pipeline on the computing continuum, where different parts of the pipeline then will execute from the edge on the one side with the actuators and sensors, through the fog, to the cloud, to the HPC, and again back to the edge for the interaction. So there are also other projects working on orchestration and choreography of these pipelines. And we also see interesting synergies with that in the TransContinuum initiative, which we'll hear more about in the session on Friday. I mentioned that we are all mostly familiar with Industry 4.0 and manufacturing. So I'll take a starting point now in Destination Earth, which you also all will get familiar with soon. It's one of the big initiatives now in Horizon Europe and also in Digital Europe. And digital twins are a core part of this, creating models of the Earth for sustainability analysis, predictions, and associated activities. We come back to that. Also introduce that there are many types of digital twins. In the Cognitwin project, we have also extended digital twin to talk about hybrid twin and cognitive twin. And since we use the word cognition, also dwell a little bit on this with the following definition. Digital twin is basically a digital replica of a physical system with its associated attributes and behaviors. With a hybrid twin, we mean that there is a set of twins, typically focused digital twin models that are now being combined to become a more complex and holistic model, synchronized on time and space. And that's what we see in practice. Sometimes one is not making this distinction, but we have found that useful to emphasize that we're talking about twins or twins there. And then this can in addition be enhanced with cognitive features for sensing complex and unpredicted behavior and to do reasoning for system optimization and continuous evolution of the representations, impacting also the environment with actions and interactions. We'll come back to that also a little bit later. Getting back to the destination Earth, there was a Green Deal call towards a digital twin of the ocean, where we now have a new project called ILIAD, Digital Twin of the Ocean, where I'm the scientific coordinator. So that's why I'm kind of focusing a bit on this. And as I said, the context of Destination Earth, this is from the Destination Earth, which is a wide area, not only the ocean, but also land and coast and basically everything about the planet. Digital twins is a focus area for various aspects of models of the Earth. So we will find a lot of calls, projects and activities in this area in the future. When we have applied this to the digital twin of the ocean, we have used the same life cycle reference model here, looking at data acquisition, data representation, hybrid models, visualization and feedback. And this is a large project, 50 plus partners, 18 plus million euro. That is starting now in February for 3 years. That will work on models for digital twin of the ocean, collecting data from a lot of sources, about real-time and historical data, using a lot of existing systems as well as in situ observations and sensors and actuators, different kind of existing data platforms, using IDS and Gaia-X as input foundations for some of the federation of data. A lot of different models of the ocean from many different perspectives. We really see twins of twins here. There are literally hundreds of different models that are relevant in this context to be combined, linked to high performance computing, linked to AI and machine learning. So it is a perspective that will grow. And it's an interesting question, is this the same digital twin as we have in manufacturing and in process industry? Will the asset administration shell work in this context, or are there overlaps and synergies? So this is what we would like to explore in the coming months. We also explore the usage of Gaia-X and IDS as support of ocean data spaces and interoperability data space, and to see to what extent this architecture can be harmonized with the needs for ocean information models, federation of data and services, and also an ocean interoperability data space. So there will be not only this, but there will be a lot of other digital twin projects that will be called for under the Digital Europe program, and also other programs under the umbrella of Destination Earth, where we hope to find synergies with the manufacturing and also other digital twin approaches. Now a bit back to the process industry and the Cognitwin project, looking at the cognitive digital twin pipelines. I mentioned this as an approach that is following our life cycle toolbox structure, from data acquisition to twin representation to the cognitive hybrid models to visualization and control. So what is in black here are typically open source or standard technologies. In red are things we are doing in the Cognitwin project. And we see a lot of commonalities with the other 5 projects I mentioned. So we try to harmonize also across those in the process industry, as well as for the manufacturing industry, where there's a lot of commonalities that has been identified already. Also digital twin representation. We are experimenting now with the AIS, which we think is quite suitable in the manufacturing domain, both in the continuous and discrete manufacturing. We will be looking into data spaces for data sharing. And of course, there are specifics aspects in machine learning, and particularly for the physics, but also a lot of commonalities also for the visualization and control. And the fact that the processing here goes across the whole transcontinuum, supporting HPC, AI and machine learning, and the edge both as input and output and actuation and control. So we hope to explore this further, also other dimensions of digital twins from initial definition, evolution, and the usage of digital twin perspective through the whole life cycle of the environment that we have an interest for. So this has been applied in a number of projects where things starts to be quite concrete. I will not go into the details of that, but all of this can be found in the 6 pilots we have in this project, where we then, of course, look at concrete actuators and sensors, OPC, MQTT technologies, data space sharing, event handling, and various forms of models, digital twins with both data-driven models and physical models, and user interaction and control. So these are just to illustrate instances of this approach, where of course the various sensors will typically vary. Some of the underlying infrastructures might vary depending on existing systems. How we deal with modeling, both data-driven models, machine learning, and physical models for the hybrid combinations, and also the interaction with the environment. Further, the cognition part is currently being worked on, extending the intelligent behavior for the analytics feedback with environment and with users, also using user knowledge and to bring in operator knowledge and additional knowledge into the context there for the system's understanding of the environment. Just another example here, illustrating that there is a more or less mostly commonalities, but of course also differences when it comes to the particularities of different systems and environments and the pilots themselves. So we have 6 of these in this project, and we have the 5 others. So there are 20 plus pilots similarly that we work on. And we will come back to this on Friday. The last session on Friday is on data-driven intelligent digital twins, where we'll present some of these from the projects. Also look at the various domains we have, not only the manufacturing, but also the digital twin of the ocean, also other domains such as building and construction, to try to get some understanding for the similarities and differences, and to basically start an activity to look for synergies between all of these various digital twin projects. Note that you have probably already heard about the IoT twins that was presented earlier this week. We have Vessel AI being presented now after this talk. We have data spaces enabling city digital twins also being presented today. We have on Friday in the afternoon digital twins in the manufacturing, and particular focus of the asset administration shell with Rami. In parallel, after that, we have Transcontinuum initiative and its impact on data-driven information. So we see there is a lot of activities that are relevant here, and we will come back to this on Friday in the last session, try to see potential synergies and also discuss the way forward on synergies between all of these different digital twin initiatives, so that we are not only working domain specific. Of course, we have to do that too, but we hope in particular also to be able to create synergies between all of these digital twin initiatives, both in projects and in standards. This is what I plan to present now, but I hope you will follow up on this on the other sessions during the rest of the week, and also to join our final session on Friday for further presentations and discussions of this. Thank you for listening to this.
Hello, good morning to everyone. Welcome to the session of Vessel AI, so on enabling maritime digitalization by extreme scale analytics, AI and digital twins. My name is Carlos Agostinho. I'm here today as the dissemination manager of the Vessel AI project. However, I'm also a researcher at Uninova. So my work here and my role here today is just to manage the session. So I will now start just sharing my screen. And while doing so, I will turn off my camera just to avoid any potential problems with the sound. But my speakers will keep their cameras on so that you know who everybody is and know and keep track of the session. Okay, so I hope you can now see my screen. So like I said, so we are a session on maritime digitalization. Vessel AI is a project on AI, but our domain application is actually maritime. So I think it's quite a different topic, but very interesting as well. And the motto for the session is actually the huge amount of potential that we have within this domain of areas. So shipping is actually one of the most important areas in our economy. It has a lot of potentiality. It has also a lot of problems. So it's one of the leading sources for greenhouse gases. It has high impact in terms of incidents, especially in heavy traffic areas. It is generating a lot of data that every minute that still remains a bit unexplored. And Vessel AI comes in actually to try to tackle and work with this data. Combine here high performance computing, big data, AI technologies, and provide some solutions in terms of, for example, prediction, modeling behavior of vessels, design of the energy systems, working on unmanned vessels, optimizing routes, so such things. I hope that today our session is can be able to give you a quick look into what we are doing, and we are fully open, of course, to talk with you guys after the session, and even during the session we have time for a couple of questions. So the first speaker today will be Dr. Spyros Mouzakidis from NTUA. He is representing here the coordination of the Vessel AI project, and we will introduce a bit more details about the project and our MVP. So we have more or less 1 year of duration. So we are still defining the structure of the project and how things are going to be worked. Then we will have Jaakko Talonen from Napa, one of our pilot cases. So to give you a look of what we can do with the technology inside the project, or what we want to do. Then one of our technical partners, represented here by Christos Zoukarides from University of Piraeus. He will talk a little bit about one of the technologies that we are applying in the project. And we will conclude then with Vangelis Karakolis from ICCS, talking here about the synergy that we have ongoing, namely with this iron energy project. So it will give you a little bit of heads up on an open call that's happening right now, and how we can all take part on it. Before passing the word, just I would like to leave you with this link here. If you can help us out, we are actually producing a questionnaire for stakeholders. So not only industrial stakeholders, but also stakeholders related to the academia with research. So in the session, in the scope of the session, we are quite interested in people coming from the big data, machine learning domains. If you can spare 5 minutes to answer our questionnaire, it would help us a lot. and so I won't take you much more time. I'm passing now the word and the floor to my colleague Spiros. Spiros, go ahead.
Thank you very much, Carlos. Yes, you can see my screen now.
Yes.
So, hello, my name is Spiros Mouzakitis, and I'm a senior researcher at the Decision Support Systems Laboratory of the National Technical University of Athens. And I am the technical coordinator of the Vessel AI project. The project has started in January, and it has a 3 years duration. It was funded under the call of Big Data Technologies and Extreme Scale Analytics. The consortium includes 13 partners from 6 countries. We have 6 pilot partners that are considered pioneers in the maritime technology and intelligence, as well as 7 technical partners with expertise in data engineering and analytics, high-performance computing technologies, and AI acceleration and artificial intelligence. So we have a good balance and collaboration between the technical partners and the domain experts, which is a key ingredient in artificial intelligence projects. So you all probably already know that the end of 2021 finds that the artificial intelligence, HPC, and big data, they are in the forefront of maritime digital transformation. And the maritime industry needs to embrace it in order to meet the increasing demands in terms of safety, security, environmental impact, and energy efficiency. To get a glimpse of these needs, there is still a considerable amount of accidents and incidents happening with the ships, with the majority of these accidents to be attributed to a human error. You will all remember also the recent accident in the Suez Canal of the Ever Given, which had a significant global effect, not only in the shipping industry, but also in the global economy. At the same time, shipping is responsible for a considerable amount of global gas greenhouse emissions that are projected to increase significantly with the next years. So the key to address these challenges is to research and development of new technologies that take advantage of the large amount of data that are being generated by the shipping industry and the maritime industry. This includes distributed and extreme scale data processing technologies in memory databases, parallel processing, streaming SQL. There is an advantage in machine learning and deep learning, as well as reinforcement learning, such as artificial neural networks, convolutional neural networks, LSTMs, boosting algorithms, as well as federated learning and automated process for the machine learning part, as well as the convergence of the HPC architectures and technologies with the popular AI frameworks such as TensorFlow and PyTorch. So all these technologies provide new opportunities for a diverse range of current maritime applications, including vessel traffic monitoring and management, the ship energy system design and operation, autonomous shipping, fleet intelligence, route optimization, fuel consumption, and predictive maintenance. So one such key technology, which is gaining more ground, is also the use of digital twins. So basically, a digital twin is a digital representation of a physical entity. The physical entity generates real-time data from the sensors that feed the digital model. So the digital twins give the opportunity to optimize time and money through the continuous monitoring, simulations, and analysis of the assets, process, and basically all the variables that are relevant to the digital model. So you can have, let's say, for instance, the digital model of a ship or a car or an airplane or the whole port or the airport. So the digital twins are also very vital for the training, for generating data for the training of machine learning and deep learning models in a simulated environment, especially in case where ground truth observations are either hard or rare to get or very costly to obtain. So what is the major obstacle for the maritime industry? It is that in order to adopt all these technologies, they have limited effort. That also is translated to high cost, especially in terms of the infrastructure and the resources to train such models, and limited expertise. In terms of the technical challenges, integrating physics-based and data-driven simulations poses a lot of challenges, including the efficient ingestion and curation of the data sets that are coming from different sources, for instance, meteorological data, oceanographic data, and the data coming from the maritime industry, and the complexity and the accuracy of the machine learning and deep learning models that need to be trained and validated. For instance, checking the bias, checking any other issue that may come from the machine learning models. So there are unexploited opportunities that have risen from the enhancing the current HPC architectures with AI acceleration that would be key for maritime industry cases, since it generates too much data and it causes and it calls for extreme scale analytics. So this is where the Vessel AI steps in with the goal of creating a novel framework to overcome such challenges based on a combination of HPC, big data, and AI technologies. It is capable of performing extreme scale and distributed analytics in order to fuel the next generation maritime application and digital twins. In the projects, we're going to have 4 pilots. The first one is about ship modeling for global vessel traffic monitoring and management, led by marine traffic. The second pilot is the globally optimal design of the ship energy systems by VTT. Autonomous ships in short sea transport by Syntec Digital and Syntec Ocean, as well as Kongsberg and Masterly. And the fourth by NAPA, the weather routing and fleet intelligence service in the shipping. For all these pilots, the plan is to create a large number of machine learning and deep learning models, including vessel route forecasting, vessel traffic flow forecasting, collision risk assessments, any type of models that are vital for the shore control center that it is monitoring, basically the operation of the autonomous ship, including route clustering, anomaly detection, as well as many other models, such as a surrogate model of the ship energy system performance, and so on. So the idea here is to take all to gather the data coming from both the pilots as well as the public data, and to create machine learning and deep learning based on these data sets by addressing the challenge we mentioned before. And the training and deployment of the models be supported by a novel HPC infrastructure that also includes AI acceleration technologies, in order to offer novel service to be consumed by the pilot services that will thereafter evaluate, their added value will be evaluated by the end users, which are the maritime stakeholders. So this picture depicts the overall architecture of the MVP that we're currently planning. And a basic principle that we wanted to follow in our architecture was to avoid having a monolithic platform that its components are hard-coded and not reusable. Therefore, we followed a modular approach where each data processing or machine learning workflow is created and managed dynamically our current plan is to use Airflow, for instance, so someone can dynamically create such workflows for any step of the data processing, including the ingestion, the preparation, the data transformation. And from the part of managing the life cycle of the machine learning models, we also want to use dynamic workflows and monitoring. And our current plan is also to be based on the MLflow. And so the models that have been created, such as the vessel route prediction, will be wrapped as services and thereafter being deployed to be consumed by the external maritime applications. At the same time, we will implement a data analytics environment for the data scientists in order to perform small-scale experimentation using, for instance, Jupyter, Grafana, and Superset. So here you can see our current planning. Currently, by the end of December, we're going to have our internal first version of the data HPC and the AI services and models that we will create. Then it will be followed by integration. The first alpha version is expected by end of March of 2022. And thereafter, we will have the first results from the evaluation of the initial datasets. So part of our public results of the projects will be shared by the AI4U repository. As you probably most of you know, the AI4U will be the one-stop shop of Europe for AI resources. So having again the reusability in our mind, the idea is to have any type of assets that will be created in Vessel AI, and they are bound to be released as public. We will be linked in the AI catalog of the AI4U, as well as being wrapped in the proper format in order to be also shared with the marketplace of the AI4U experiments, which is based on the Akumos platform. So you will have in the next presentation to have the opportunity to get a detailed glimpse of one of our pilots. In the meantime, you can follow us in LinkedIn and Twitter because more exciting news are coming our way. So now it's time to pass to the next presentation. If we don't have any questions,
let's just see if we have some questions on the chat. Thank you, Spiros. So no questions in the chat. So I think we can pass the floor to the next speaker. Christos, go ahead, and I will ask all the remaining speakers if they can keep the cameras on. It would be nicer.
Oh, sorry. Okay. Carlos, was me. Who is the next?
Sorry, Jaakko, yes, it's you.
All right. Please note me if you see the screen.
Yes, it's perfect.
Okay. Great. All right. So, as you said, NAPA is one of the pilots in Vessel AI. And NAPA is a company which provides software, services, and data analysis for ship design and operation. And in this pilot, we are concentrating on weather routing and optimized fleet operations. And in this presentation, and recently, we have concentrated on fleet operation analysis. And the scope here will be related on the port data and how we can improve it and keep up to date with big data, meaning in practice AIS data. So I have been 3.5 years a data scientist at NAPA, and my background is I have a pretty long background in Aalto University. I'm a doctor in computer science, and you can see our Twitter accounts and my personal account, mostly tweeting about R language. And in this project, I have taken part to work package 6, and goal has been on implementing the scientific innovations in practice to our products. And my closest colleagues are Teemu Manderbakka and Kimmo Laaksonen. And so today's agenda is birds. And we have our improved database containing metadata related on ports and terminals, locations, and then there is open data, World Port Index, and UNECE, United Nations Economic Commission for Europe. They provide data, but one challenge has been the quality and the fact that new ports and terminals are constantly built. And there is no global database related on birds. And it's also hard to manually collect the data. So the first question is actually why we need bird locations. And I have worked mostly in the AS data in my past 3 years, and I have noticed that it's actually, there is certain challenges how to analyze the global fleet or how the ports serve the vessels and which frequency or efficiency. And I think also quite the important thing is that if we use AI's data that we can get all the time, we can use that to keep our database up to date. So first, something about the AIS data. So it contains vessel speed and locations, metadata such as dimensions, and also manually inputted data such as navigational status. But as you can see in this photo, the vessel is not moving, and based on AIS data, we are actually not able to detect whether the vessel is in port or in anchorage area. Of course, like analyzing the data, if the vessel heading is having some kind of standard deviation or it's moving, probably it's at the anchorage area. And the navigational status is updated manually, so it can be possible that it has some delay of minutes, hours, or days, or it's not updated at all. So in our recent research, we had a goal that we try to detect the birds based on AIS data. So first step would be to detect the vessels and as spatial polygons. And then the vessels can be moved very different ways and different places depending on the locations of the cranes. So we need to define how bird is defined, and we end up to the solution of birds as blocks. And next I will go by examples, what this means in practice and what we have achieved in this project. So here is Los Angeles and Long Beach, which has been in the news that they have some troubles with the container vessels, and the current data, a priori information about the locations of the ports. And for example, UNECE data source, we can see that there is ports completely in the wrong locations, and then also accuracy, the precision of the data is in UNECE, it's 0.016 degrees, so meaning 1 minute, and depending on the location in the globe, it's some 100 meters, and then we can see that the locations are in the kind of grid shape. So with analyzing 1 month of data, this October 2021, we can quite nicely find the locations of the birds, which are shown in this figure as these shiny light blue boxes. And we can also define the sizes of the vessels that has been in that part of the bird, and then direction, and then map to the closest known ports or terminals. And below the picture, we can see the number of the ports and terminals in our database. And here in this slide, I show that we have cooperated quite much. Personally, I have been operating with Jussi Steenari from Helsinki University and discussed about the methods. And one method that we have implemented in practice is this density-based spatial clustering, DBSCAN, to decrease the number of birds which are overlapping. But as I said earlier, the challenge is that the different size of the vessels can be moved in different places on one bird. So probably there is only like, it depends on definition, but there's three different birds, but we have defined it actually quite many blocks. But one benefit in the blocks is that we can even detect that one crane was not used in October 2021. Okay, we can think later how we can use this information. Anyway, so big data, it's actually much more AS data per day than 2 million points. But with the 1 hour frequency, it's about 2 millions. And then there is different aggregation. In this particular case, we are interested about vessels that are moved and not moving. So we can aggregate and filter the data depending if they have the heading information and stuff like that. And finally, we get 50,000 bird locations, and after DBSCAN cleaning, 38,000, of course, depending what kind of vessel types we select and so on. So, summary. On the left, we can see from our database that it's actually, we have a terminal, future container terminal. One challenge is still the updating the names, but it's not so important for monitoring the global fleet or port operations. But we were able to detect that these light blue boxes are actually container vessels and also different type of vessels. And we can define different metadata to the birds. And kind of being honest that it's I don't know if it's paradise, but at least many new research questions can be opened, and we can get business value by analyzing the congestion times or anchorage time, and also decrease the CO2 if we can investigate or make better research how vessels are operating currently and how we could improve that. So that's what I have to say today. So still implementing the vessel area findings and methodologies to products in future. So thanks. Any questions?
Thank you, Jaakko. Let's just wait 1 or 2 moments just to allow for the feed to be synced and see if there are questions.
Anyway, if it's technical or detailed, you can, of course, email to me, and I have my time to answer.
Okay, thank you very much. I think there are no questions in the chat.
Thank you.
Thank you, Jaakko. So we will move now to the next speaker. Christos, you have the floor.
Yes, thank you. I hope you can see my screen now.
Yes.
Yes,
perfect.
thank you very much. So, hello everyone. My name is Christos Doulkeridis. I'm an associate professor in the University of Piraeus in Greece, the Department of Digital Systems, and my area of expertise is data management. Today, I will talk about the problem of data integration. So, in many different application domains, we have data that come from very diverse data sources. This is also the case for the maritime domain, where we have data such as positional data of vessels. We have geographical data such as, for example, fishing areas or protected areas. And we also have weather data in the form of forecasts. And also there are different ways to access this data. So some of this data may be stored in files or databases. We call them archival data, but we can also have streaming data, such as the positions of vessels. And these streams are usually noisy, and also they are quite bursty. So the problem is how to provide a common semantic representation over all this data and interlink this data. And in our work, we have selected RDF as the way to represent the data, since RDF is the de facto standard that is used on the web for open and linked data. So the challenge that we need to face is that we have different data sources. We have positional data, we have weather data, geographical data, and so on. Different representations. Data can be structured, or they can be semi-structured or even unstructured. We have many, many different formats like CSV files, JSON files, XML. We can have shape files, binary files, data stored in databases, and so on. And as I already said, there are also different ways to access the data. You can have historical data or streaming data. So the problem that we try to solve is, given a set of, let's call them raw data sources, and also given an ontology that describes our domain and gives us a schema, how to perform data transformation from these raw data sources into an RDF graph. This is the problem that we try to address. Our approach is called RDF-Gen. When we started to work on RDF-Gen, we had some design goals in mind. So we wanted to have an extensible solution. We wanted to support both streaming and archival data. And we also were very interested in a highly efficient solution. That means a solution that provides low latency and high throughput. And also, because we want to apply our solution on big data, we were also interested in scalability. So with that in mind, we designed and implemented RDF-Gen. RDF-Gen is a flexible tool for data transformation. It requires an ontology that defines the schema of the data that will be produced. And it consists of three main modules. The first module is the data connector. The data connector separates data access from data transformation. And we provide many different implementations of data connectors for different data sources. The second module is the graph template. The graph template practically defines how the RDF triples will look like, how the RDF triples will be output. And this is in accordance with a given ontology. And finally, the third module is the triple generator, which takes as input the values from the raw data sources and converts them to RDF based on the graph template. Let's see a more concrete example. Here we have a data connector. We can select what type of connector we want to use. For example, we can have a connector for a CSV file or a connector for an XML file and so on. And then we provide some additional configuration parameters. For example, for a CSV file, we need to specify the delimiter. For an XML file, we need to specify the basic XPath expression based on which we are going to retrieve data from the file. And then the data connector can access the input source and provide data on a record by record, in a record by record fashion. For example, here you can see a row from a CSV file. And then we can associate variables. We have a list of variables that are associated with the values of the input record. And on the top right, you can see a graph template. This is expressed in turtle format. This is just a syntax for expressing RDF data. And in this graph template, we can use the variables that were defined earlier. And these variables, they provide bindings with the actual values of the input record. And not only that, we can also have user-specified functions that are used in the template, which can perform various interesting tasks. For example, we can convert units from knots to meters per second using this function called knots to meters per second, or we can construct geometries from the longitude and latitude coordinates of the objects, and many other things. So we have these user-specified functions. And eventually, the output will be a set of RDF triples, again expressed here in turtle format, which is practically the input records, but now in the form of RDF and in compliance with a given ontology. So as a graphical example, here you see part of the RDF graph. In the left part, you can see the position of a moving vessel with its speed, heading, the course, and so on. And also, this position can now be linked with the prevailing weather conditions. So on the right, you see the weather conditions, for example, the wind that was prevalent at that location and at that specific time. Interestingly, with RDFGen, we can build flexible workflows of data transformation. Here you can see 4 examples. In the top left example, it's the simplest case where we have multiple sources, but we have an RDFGen instance for each data source. So here the transformation happens individually. But on the second example, on the top right, we have the example of 2 RDFGen instances. The first one on the top is accessing the stream of positions of vessels, whereas the second one is accessing the weather conditions. And for each incoming position of a moving vessel, we can request, we have a data request, we retrieve the related weather values, and then we can produce these linked RDF triples that you saw earlier in the example. We can have more complex workflows. On the third example, at the bottom left, we have more than one data sources. And quite often we need to associate the data. We need to join the data from different data sources prior to data conversion to RDF. So this is also feasible using RDFGen. The data connector can perform a join algorithm between the data sources and then provide the joint records as input for RDF data transformation. And last but not least, on the bottom right, you can see the parallel version of RDFGen. If we're interested in having high throughput, or if we want to target big data sources, then we can have multiple instances of the triple generator that run in parallel. And in this way, we can increase substantially the rate of data conversion. Some indicative performance results. We have implemented RDFGen in Java as a centralized software, and we also have a data parallel implementation in Flink. In this example, we transform a simple CSV file to RDF, and on the horizontal axis, you see the size of the file. So we use files with increased size. On the vertical axis, we have the throughput achieved by our solution. So the yellow bar is RDFGen, and as you can see, for a simple CSV file, we have a throughput of approximately 9,000 records per second, which is much better than the state-of-the-art approaches like SPARQL Generate and RML. So RDFGen is quite efficient, and in case we need higher throughput, we also have a data parallel version that achieves better results. So to summarize, RDFGen is a flexible tool that can be used to build RDF knowledge graphs from multiple diverse heterogeneous data sources that can be both archival and streaming. It's an efficient solution. It can run in parallel, and it also comes with extensibility features. That means that one can easily implement new user-defined functions, and these functions can then automatically be used by a graph template. And as I already tried to show, RDFGen can support different workflows of data transformation to RDF. So that's it from my side. Thank you for your attention, and if you have any questions, I'll be happy to answer them.
Thank you, Christos, for your presentation. I think it was quite illustrative of some of the technologies that we are handling inside VesselAI. So I'm checking here the B2Match system to see if there are any pending questions. Not at the moment, as far as I can see. So I guess our viewers are a bit shy or are fully clarified with the presentations. Anyway, just a reminder, we left our contacts in each presentation and also in the chat. So if you have any questions, we are more than willing to talk with you offline. We will also be available on our booth today, so feel free. Thank you, Christos. So getting back here to the flow of presentations, we can move to the final one. Vangelis, you have the floor.
Thank you very much, Carlos. Let me share my screen. Delay. All right. Hello, everyone. This presentation is about iEnergy project, with which VesselAI has a synergy. iEnergy project is about artificial intelligence for next generation energy. I will also present the first open call of iEnergy, which is in progress. I'm Vangelis Karakolis. I am a researcher for ICCS, the Information of Communication and Computer Systems. My professional work focuses mostly on big data and AI on the energy domain, and I am leading the AI work package in the iEnergy project. So a few words, what will be presented in this presentation, a few facts about the project, the consortium, and a few information about the partners, the motivation behind iEnergy project, the mission and objectives, and also the relation with the AI4EU platform. I will also present the pilots and the open calls, focusing mostly on the first open call, which is in progress, as I already mentioned. I will give a brief overview on the high energy conceptual architecture and the services that are developed and will be developed in the future. High energy started in the beginning of 2021, and it lasts 36 months. The coordinator is the Institute of Communication and Computer Systems, ICCS. It's a Horizon 2020 project. It's funded from H2020 Research and Innovation Program, and its budget is around 5 million euro. And here in the bottom right section, you can see the grant agreement number. A few words about the consortium. Well, it consists of 17 partners from 9 countries, 7 leading research and academic institutions, SMEs, and established companies with leading expertise on AI, ICT, and data in the energy sector. One partner is Funding Box, which cascades funding to startups and SMEs. And there are 9 EPES stakeholders covering the full energy value chain for power network operators, including TSOs and DSOs, to aggregators, to ESCOs, financing institutions, etc., etc. A few motivation behind this project. Well, artificial intelligence is bound to revolutionize the energy sector by providing fast and accurate forecasts, demand and supply predictions, grid flexibility, optimized maintenance, and optimal operation. Also, AI proliferation in the energy sector holds the premise for a larger environmental and social impact by providing value through decentralization, democratization, and digitalization of energy, environmental sustainability, and the alleviation of energy poverty, and also fighting against climate change and environmental degradation. The vision of high energy is to deliver an energy-specific open modular framework for supporting AI on demand in the energy sector based on the on state-of-the-art AI and data technologies, focusing mostly on energy commodities and networks, distributed energy resources, and also energy efficiency and non-energy related services. It is tightly related with the AI4EU platform, which is a one-stop shop for anyone looking for AI knowledge, technology, tools, services, and experts. Specifically, the main assets of high energy that include AI as a service APIs, applications and dashboards, libraries and codes, datasets, machine learning models that will be developed as project assets and tested on real pilot cases, and also through the open calls. These assets will be available, and some of them are already available through AI4EU. First of all, they will be published on AI4EU catalog, and also will be onboarded to AI4EU experiments. About the pilots of high energy, the overall high energy service analytics framework will be applied, implemented, demonstrated, and validated in real life pilots in 9 pilot hubs and 15 use cases, 2 test bed facilities and digital twins, and it will be done across 8 countries. Specifically, Ardinester is a TSO from Portugal. Veolia is an ESCO and district heating facility manager from Spain, and also FAEN is an energy agency policymaker from Spain. There are several pilots from Italy, ASM, BFP, and also Iron and Parity from Greece, Zeskop from Croatia, Sons from Slovenia, and Ria from Latvia. Now, about the open calls, there will be 2 open calls with financial support to third parties, while 25 bottom-up projects will be funded, and the overall budget will be 2 million euros. The goal of the open calls is to create building blocks for use cases and small-scale experiments, along with new analytical tools. The services will be tailored for the EPES stakeholders as prototypes and new services, for example, through MVPs. And there will be 2 high energy technology transfer programs. Regarding the first open calls, which has already started about a month ago, it started specifically at the 8th of November, and it closes at the 20th of January. And the main reasons why someone should, a company should apply to this, well, it's funding, so up to 10,000 euros will be given for the first deliverable, which is the individual, in which the individual mentoring plan and a proof of concept will be presented, and up to 40,000 for the second deliverable, which is a prototype. During the next 6 months, also mentoring will be provided from My Energy Consortium. Up to 10 proposals will be funded, up to 50,000 euros. Now, about the ideal candidate, startups registered no later than the 8th of November 2021 in EU member states and its overseas countries and territories, or associated countries to H2020, are perfectly suitable for the first open call. Also, the use case should be in accordance to the scope of the project and with initial TRL equal to 3, including relevant evidence. And it's highly preferable to use their own resources. The applicants should use their own resources like modules, models, and components. The scope of the first open call is to develop building blocks and applications for new AI algorithms and services and small-scale experiments to address the development and implementation of technology and systems applicable to specific cross-sectorial challenges within the energy sectors. Now, the purpose of the first open call is to enrich the AI resources and tools catalog for Energy on Europe's AI on demand platform. Here we present the key challenges and the areas of experimentations. Indicatively, some areas of experimentation are AI applications on energy, data governance and valorization for energy services, monitoring and energy usage optimization, predictive maintenance, etc. While a few challenges that we have the ambition to be addressed are presented in the right section. Some of them are AI for network assets predictive maintenance, AI for load and demand forecasting for efficient operational planning, application of reinforcement learning in energy systems, etc. Now, about how someone can apply, the link is provided on the top of the page. So someone has to sign up to Funding Box to open the application form. The user has to read the guide for applicants and the frequently asked questions and join and explore the iEnergy community. That's all for the first call. And now a brief overview of high energy conceptual architecture. Here is the overall conceptual architecture of high energy. In the bottom, you can see the data management services, including data storage, data ingestion, data harmonization. The main technologies for the data management services will be Apache NiFi, Apache Kafka, and MongoDB. One layer up, we have the AI models training suite on the right side, and the energy analytics services and application on the left. Regarding the first one, it includes several services and tools to facilitate model training and evaluation, such as the model serving framework, the high energy AI model storage, model evaluation, incremental and distributed learning, etc. And on the left side, we present the services for the end users. Such services and applications can be predictive maintenance service, the energy forecasting, the flexibility forecasting service, as well as the applications for digital twins, visual analytics and reports engine, and also the high energy marketplace. And also applications and services developed in the context of open calls. Regarding the infrastructure, we are examining the synergy with the project EGIAs to provide us with GPUs and computational resources in order to train and develop our models. And Gaia-X and several datasets will be hosted to Gaia-X project. Now, on top of these services, there is a security and access control layer, which secures that only authenticated and authorized users will be capable of using high energy services and applications or access high energy data. And finally, the high energy assets that have already been mentioned before, like datasets, machine learning models, and the AI as a service APIs, will be available through the AI4EU platform, and specifically AI4EU catalog and AI4EU experiments to EPES stakeholders. And last but not least, some high energy services are energy load forecasting, predictive maintenance, operation planning, digital twin for distributed energy sources and electrical communities, energy flexibility forecasting and demand response, etc. This concludes my presentation. Please, I am available if you have any question. I would like also to suggest anyone who is interested in this project to follow us on LinkedIn and Twitter through the links provided here.
Thank you, Vagelis. Thank you for the nice presentation and for the quick insight on the project, on the iEnergy project. So I think we had the perfect timing. Just a second to check if there are any questions. I guess not, but no. So I would like to thank all the speakers and all the participants of the session as well. Thank you very much for your presentations. I hope we have managed to give an idea of what we are doing to our viewers. We remain open and fully at your disposal to clarify any open questions that you might have pending. So don't hesitate to drop us an email, to visit our website, social media, and so on. Thank you very much for your attention. Goodbye.
Thank you.
Okay. Well, good afternoon. Let me start sharing my screen. Sorry. Okay, I think you might be seeing the slides right now. So good afternoon. This is Elena Montiel, and together with my colleague Victor Rodriguez, both members of the Ontology Engineering Group, a research group at Universidad Politécnica de Madrid. We're here today to share with you our experiences in the creation of legal knowledge graphs. Yes, and some some developments also related with this. Well, experiences that we gained in the context of the LINKS project, a European innovation action that ended already last March, but which also belonged to the family of BDVA projects. Okay, here you see all the entities that participated in this exciting project. Universities, research centers, companies spread all over Europe, plus an Israeli company. So why did we decide to create a knowledge graph in the context of the LINKS project? Well, as you may be well aware of, right, knowledge graphs can be defined as collections of pieces of information that are connected. Yes, they consist of entities, yeah, concepts we have data or we want to say things about. These are the nodes, let's say, and we connect these entities to other entities by means of edges or relations. So in the end, what we have is a graph. So the main benefits of knowledge graphs, I think, are also well known, right? So the idea is they allow us to bring unstructured and structured data together. They allow us to generate unified views of heterogeneous and initially unconnected data sources. The resulting data sets can also be used to train machine learning algorithms, yeah, well, and so on and so forth. So basically, knowledge graphs, as one of my colleagues in the project used to say, are an efficient way to work together. And obviously, we are not the only ones that see the benefits of knowledge graphs, right? According to this Gartner consultancy firm, yeah, right now, many expectations are being raised by knowledge graphs, and we do see the benefits. So for our LINKS project, yes, what were the entities in this knowledge graph, in the legal knowledge graph that we created? So since we wanted to bring together, to homogenize access to legal open data in Europe, yeah, this was one of the best ways to achieve it. Having this challenge in Europe means that data is published by different official law publishers at different levels. Of course, European level, national level with all the national legislation publishers, even regional level. So legislation, so legal documents from different jurisdictions, and obviously in different languages. So the main entity in our legal knowledge graph was the legal document, what we called the LINKS document. Having to deal with multilingualism, we also wanted to have legal terms, legal concepts included in this knowledge graph. And for this, we counted on, well, traditional resources, linguistic resources that capture and define legal terms, which are multilingual thesauri, terminologies, concept schemes in several languages, right? So legal terms, the bubble in orange was another entity in our legal knowledge graph. And finally, we had legal entities, what we call legal entities, so companies, industry sectors, institutions, also defined in this legal knowledge graph. So how did we build the knowledge graph? Well, to start with, the challenges we faced in our ambition to represent multilingual and multi-jurisdictional annotated documents was that content was structured in in different manners, XML, JSON, RDF, yeah, using different formats by different legislation publishers. That there are also several standards for annotating text documents, but not always in JSON LD. That documents are also identified in different manners, although in Europe, there is this European Legislation Identifier Initiative that we also adopted, yes, but we did not only have legal documents, but also industry standards and other types of documents that were identified in different manners. So all in all, these were the main challenges we were facing. That's why we decided to create the idea of this links document. Yes, one single data structure described with and identified with ELI, with the and described with ELI metadata. We also defined a structure for this links document. We structured the document into parts according to a LKG ontology that serves as data model. Yeah, we could also rely on RDF shapes to validate these content structures, these data structures. We decided to implement everything in beautiful JSON LD, yes, so easy to consume by developers. And as for the annotations, we relied on NIF, the NLP interchange format. Okay, so here you have like the main idea behind any links document. Of course, there are other legal knowledge graphs. So depending on the needs of your project or what you want to represent, your entities in your legal knowledge graph will be others. So you may want to say things about claimants and courts and agents and dates, or you may also want to say, as we see here in the picture, the legal knowledge graph of the legislation in Luxembourg. You may want to say that one law is cited by another law, or derogates, or implements a EU directive, etc. So depending on your needs, entities and relations will be different. Very briefly, I'll refer to the technologies that supported the creation of our legal knowledge graph and links. So documents were harvested, imported from different sources and transformed into the links document structure. And then they went through an enrichment workflow, yes, to get all the annotations from NLP services. The data dumps, the public data that was harvested, even if for testing, has been published in data dumps and is available. And we also provided a portal to explore documents and formats. And yes, even if only as a kind of test and development service, here you get a view of the document and the metadata related to every document, and also to the legal entities, right? To the additional entities I was mentioning. You can also get further information about these entities and further explore them. Finally, I'll refer to the set of services, of link services that were developed within this project. Yes, for the ingestion, pre-processing, and annotation of the legal documents. All the services are nicely described and accessible from the links portal, in case you are interested. And with this, yes, I hope you got an overview of our experiences in the creation of legal knowledge graphs. And now I'll give the word to my colleague, Victor, who will further explain, yes, other developments in this regard. Thank you.
Thank you, Elena. I will resume the presentation. I will start sharing my screen, which you should be able to see now. So now what we have, Elena has presented how companies have benefited from these solutions. I will present what's next and beyond. We are the Ontology Engineering Group is a research group made of almost 40 people, including several PhD students that are doing research in the area of legal informatics. For example, we have developed a solution to identify temporal expressions. It's the leading solution for the Spanish language and the only one working in the legal, specifically trained for the legal domain. We have also the software to identify events from judgments, from sentences issued by courts, distinguishing between procedural events, someone appealed, the court ruled the sentence, and circumstantial events, somebody killed somebody. The result is two different timelines, which can be indeed represented in RDF as a knowledge graph that can be queried, etc. We have also solutions to create enriched terminologies in a semi-automated manner. Departing from a corpora of documents, we can identify which are the relevant concepts and connect them to different external resources, producing a SCOS concept scheme as an output. This is the case of the labor law terminology, which was created during the LINX project and curated by lawyers. We are currently working in the extraction of relations of between workers, employers, which are the rights, which are the obligations, etc. We have also a cross-lingual search engine. Cross-lingual means that you make a query in a language A and you get documents possibly in language B. This technology is based in topic models, and it was developed in a framework of Horizon 2020 project, but now a spin-off is being created to commercialize the product. Finally, we have a KeyQ, which is a document searcher that gives you instant results within milliseconds with queries made over millions of documents. This is supported by terminologies like those that we have seen before, and results are directly shown over the PDF, the original PDF documents. This functionality is provided through an online web application, can run in the local premises, can run in the cloud. And the takeaway message is the following. You will find these slides in the web. These slides are very rich in academic publications, but also very rich in links to product descriptions, demos, open source code, occasions, etc. We want to be your reliable partner for semantic technologies in the forthcoming Horizon Europe calls, in particular these two solutions, these two calls that these two topics that I am mentioning in the slide. And Elena and I are very happy to have contact with you for any project participation or commercial inquiry. Thank you very much for your attention. That's all.
Hi, good afternoon, everyone, and good morning for some of you, I suppose, in other parts of the world. Thank you very much for joining me today in this session. I am Nicolas Moes, as some of you might know already, and I'm going to talk with you about building trust in the AI supply chain. We have a very short session on this, so I will not spend too much time, but just so that you know, I am an AI policy researcher. I'm based in Brussels, where I closely follow the EU AI Act, and I am doing research here about how can industry focus more and try to develop an efficient compliance framework throughout the AI supply chain, which is quite complex, as you might know. I'm doing this research with the Global Digital Foundation, and that is why you can see on my slide, which I'm going to share with you right now, that we have actually a very nice slideshow prepared with the Global Digital Foundation. Let me share my screen with you. There is a quick manipulation that I have to do, and then there we go. You should be able to see my slides. So as I mentioned, I'll be talking about trust in the AI supply chain, and more than trust, I'm gonna talk to you about assurance, right? Because it's good to trust, but it's also good to be able to verify that you are right in trusting your suppliers or your customers in the case of AI. So the challenge that we have noticed with the Global Digital Foundation is that the public mistrusts AI quite a lot, right? So we have new laws and regulations coming to affect the industry and to ensure that like the consumers and citizens can finally trust AI anew. And these regulations are coming from everywhere, right? So in the EU, you might have heard of the AI Act, the Product Liability Directive, and the updates to the product safety regulations elsewhere in Europe. Like there is also work on AI and human rights that is being carried out by the Council of Europe. In the US, there is still the bill that is a bit stalled on the floor about the Algorithmic Accountability Act, which is stalled in Congress. And in China, there's been also quite a few algorithmic regulations proposals put forward. The UK has also had its own set of regulations as well as its strategy, which is quite interesting as well to see the different approaches that are taken. In all these approaches, in the regulations, like the target really is the providers of AI systems. So the provider are, for example, in the EU AI Act, are really these entities that put a system developed on the market, right, or put it into service on the market as well. So interestingly, it's not only if you develop the AI system yourself, but it's not only if you develop the AI system yourself, it's also if you just put it on the market. So if you get input from somebody else on the market, this is a first step that is quite important to acknowledge, right? Is that even if you do not develop it yourself, you can be considered as a provider of AI system if you use an AI system and put it on the market. Second, that we have to look at is the implications, which is that there is increased compliance costs for these providers, but also for their suppliers, because the AI Act currently considers that relevant third parties, i.e. suppliers, should cooperate as appropriate with providers and users to enable their compliance. This is something that the AI Act mentioned in the recital, so this is not a legal requirement, but obviously the market will quickly adapt, the industry will quickly adapt to value more these providers that are under like legal requirements, will value more the supply from suppliers that are helping them in their compliance with these new regulations. And this is not only for the EU AI Act, right? We can expect over the next 5 to 10 years, new regulations in various jurisdictions coming up, which will also make, which will also complexify the AI industry in terms of compliance. So just to give you an idea, when I talk about AI supply chain, let me provide you with a very simplistic examples. We have here an applicant's assessment tool provider, and we can notice that the training data supplier and the pre-trained model builder contribute to the creation, to the production of this tool that is used for job candidates assessments and that kind of. And we could imagine like that the training data suppliers is in touch with the model builder as well. This is not especially necessary. This is just a subset of the supply chain. Of course, there is many more things that are taking place at the same time that are represented by all these open-ended arrows. The problem in the situation is that, for example, in the EU AI Act, again, data and data governance obligations are real, and obviously, like the person, the actor in the supply chain that has the most effective control over it would be the training data supplier, right? And in the case of like requirements for accuracy, robustness, and cybersecurity, which is that, I mean, this text is like copy pasted from the legislation currently being proposed and currently being discussed in the EU, right? So these requirements for accuracy, robustness, and cybersecurity are better addressed and are better complied with by the pre-trained model builder, which is considered as a supplier. And this is something that we have to consider, is that different suppliers will have different requirements. They will have effective control over different requirements. Another example would be like, as a supplier, you provide, let's say that you pre-process LiDAR data for autonomous vehicles companies. You do that, this is your core business, and you rely, let's say, on open source algorithms and open source research and development, let's say like GitHub and other suppliers, in order to improve your own products. Well, here again, the requirements are not limited to these 3 players, right? There are many more players that could be entering in this case. And once again, like, there are different requirements, for example, record keeping policies for different players. And here you have, again, accuracy, robustness, and cybersecurity, which might apply. Like, open source supply is a big deal in the AI supply chain. So this is something that we have to acknowledge. A third example, really to hammer down the point here, is take the example of a supplier of a speech recognition system, which would, like, again, have on its own, it has suppliers of like data, so data set suppliers for different languages. Then they sell that to a certain smart speaker company, which you can, you know, like there are many on the markets now. This is, of course, something that, again, we have different requirements that are put through the regulations, and we have different actors that have to fulfill these requirements. Like, they have effective control over the fulfillment of these requirements, even though legally only the smart speaker company would have to satisfy those requirements. And yet, like, when we think about it, there is a bit of like complexity that is added, because as a supplier, you have multiple clients, right? So what if the smart speaker company that you see, like the first one that you saw, has a different way from asking for compliance data, as a different way of asking for compliance data than the second company, or that in a totally different sub-industry, let's say, there would actually the possibility to have like different compliance systems. So it would become very messy very quickly if, like, all of these companies were asking to prove like compliance with these requirements in different ways, right? So there is an importance in having a standardized approach as well. And of course, as usual, like, this is much more complex than just this aspect, right? This is a simplistic view of it, but I'd like to provide it as well for you to understand a bit better. So, like, the opportunity that we see is that there is a need for a standardized approach to cooperation and to providing assurance in the supply chain, right? The business case for that is quite clear. It reduces compliance costs for the providers, but also for the supply chain, right? So the suppliers themselves will have their compliance costs, like their indirect compliance costs, let's say, reduced. It reduces the liability risk, because by knowing if you provide assurance, you know, and therefore you can be more confident that there is less risk of incident and accident, there is less risk of miscommunication, and that, oh, we forgot to comply with this, or that kind of question. And this is also reduced. And in addition to that, it contributes to building public trust. I mean, I don't want to claim that it would resolve everything, but like, the idea is to also like contribute to a regain of public trust and like averting the techlash. The work that we have done so far on this project has been quite long, right? It's been the past 12 months. We have actually discussed with quite a lot of providers and supply chain companies in the AI ecosystem. We have also talked with some standards bodies. We have developed a minimum viable solutions for this standardized approach. And like in itself, this standardized, this minimum viable solution, taking again the example of this three node supply chain, which is just like a subset of the supply chain, which is much more complex usually. This minimum viable solution, it really relies on like the creation of templates for assurance files. So these files would be forms asking a set of questions, but the questions would be always the same, right? So they would be the various actors in the supply chain would fill and share these assurance files amongst themselves, right? In a pre-specified way. The form itself is like function specific, so you would have an assurance file for a data supplier, right? So the template is like is to define like a certain role in the supply chain, and that role, the actors that fulfill that role in the supply chain would have to answer this assurance file, this specific type of assurance file. And there would be another one for the pre-trained model builder that has an assurance file to fulfill as well. But then the answers to the questions that are listed on this form would be specific to the AI system that you are developing, obviously, right? So because there are different tests, if you are developing something that relies on computer vision, there are different tests of accuracy and robustness. If you are developing something that relies on natural language processing, there might be also different, even further tests that need to be done. And therefore, that's why the AI system each of AI system is having a set of assurance files associated with it. So to give you an example, the data suppliers assurance files could look like this, right? So this is very quick, just for illustration, like the need here is to address, make sure that people are on the same page about the intended purpose of the AI system, to make sure that they are talking about the same AI system, and that they are really identifying like what is the use case for that AI system. This is a concept that is very important in the EU AI regulation. And that's why this would be asked to the data supplier as well. And in the data supplier is asked to describe like one of the many questions. There could be like 20 or 30 or even 40 questions and tests to run in each assurance file. But one of the questions would be specific to the description of the data selection and how the data was labeled and that kind of questions, right? So once this is filled, once the data suppliers fill that, the data suppliers sends it to the oh my god, there is like some bugs on my slides. I apologize for that. And so the point would be to share these files with other actors of the supply chain that are relevant, right? So here, like for the pre-trained model builder, it might be relevant for the pre-trained model builder to understand what is the training data that's gonna be used. We could imagine that the pre-trained model builder has its own assurance file to share as well with the rest of the relevant players. And so the questions would be different in that assurance file, right? So these questions would be about how the model was trained, what measures were taken to ensure accuracy and robustness, and also what are the tests, like the commonly accepted tests of robustness maybe that could exist, right? So these assurance files would also provide kind of a step-by-step process to ensure that people properly measure and assess their compliance with different requirements. This is, of course, like will rely a lot on like the standards being developed. So the standard procedures to test robustness, for example. We see this. We see effectively again like this that the files would flow through the supply chain based on the relevance, right? So, for example, the pre-trained model builder does not have to share a file with the training data supplier, because the training data supplier, it doesn't matter what the model is being used, perhaps right in this situation. Maybe in other situation it will matter. We don't know. And that's why like the flow of assurance file in this case from the pre-trained model builder goes only to the provider, so that the provider can then look at these files and compile them. So this is a small example, but as you can see here, like this can quickly become much more complex, right? So we have a various stepwise process. I won't go in the details here, but effectively you could imagine the actor in charge of product development taking the responsibility to send a first file describing the AI system alongside, let's say, we could imagine like alongside the signed contracts for the supply chain, and like sending them out to the data suppliers, to all the actors that might be relevant in that supply chain, right, and that they have accepted with. There is a need for then like addressing any potential issues within the supply chain itself, right? So, for example, as I mentioned earlier, the algorithm or the model builder might need to receive some information about the data sets that will be used, right? So these data sets like will be shared also through an assurance file with specific questions and with specific informations to be shared between these two type of actors, and then all the actors send back to the product development team let's say their own files with the answers needed, and so that the product development team can then compile this into a sort of like technical documentation effectively that shows that shows how compliance has been made, and they can send that to the solution provider for further processing, to the relevant regulators if this is required, to the importer, to the distributor if it is required as part of the legislation, and to the deployer of the AI system as well if it is needed. So this minimum viable solution is advantageous because it is efficient, right? It really is asking the minimum number of questions / tasks that would satisfy the maximum number of requirements, but doing that in a way that really use like who has effective control over this, to limit really the inefficient communications the back and forth that might be needed to satisfy this. It is pedagogical, right? We are going from a legal text to an actual step-by-step tool. It is adaptive to both technological and regulatory changes, because every 2 or 3 years we can easily imagine, or even every year we can imagine like updates to the templates being used, the templates of the AI forms being used. And then like the key point is that it is cost saving, right? This would really be like the single solution for industry and for compliance and quality assurance. So the next steps in our work really is to create an industry-led coalition to build and test a working solution from this minimum viable solution that I have shown you. This will require quite a bit of this coalition would provide quite a bit of input as well about the technology, about the compliance, about supply chain, about outreach, and like they will have to really have several work streams in order for this project to become a norm, let's say. And in itself, this is something that we could embody by the creation of a international non-profit organization in Brussels, for example, because this is really a legal entity format that has been created for this type of work. Of course, for doing that, like there is like your help is needed, right? So feel free to reach out. We believe that the creation of this small international nonprofit that would provide a secretariat for the organization as a whole, we believe that this could require up to 350,000 euros of funding, and therefore we are looking like for not only like for people with knowledge of the problem and co-creators and ASBL, but also for funders. And that's why, like if you want to reach out, like do use the application, like the platform that has been set for the others. Thank you very much. I do think like I am on time, perhaps to hear if there is any question. Otherwise, like I rely on tech support and the amazing organizing team for maybe getting back on track in terms of timing as well. If you have any questions, feel free to ask. Right, I'm happy to share and to answer your questions. Either right now, we have like 1 minute left, or in writing through the platform, the event platform. So I don't know if Maja wants to take back control, or Jaco. I think it might be time for you. Thank you very much.
So good afternoon. We can start. So thanks for joining this session. The session will be led by Francesca Mani and myself.
Yeah, good afternoon, everyone, and welcome to the main session of the Industrial and Trustworthy AI track of EBDVF. I am Francesca Mani from Philips Research, and together with Milan Petrovic, I will moderate this session today. So first of all, I would like to thank the speaker and the audience for joining the session, and I would like to introduce the session and then leave the floor to Milan to proceed with the speaker introduction. So the main goal of this session is to address cross-sectionally the challenges related to applied AI system and their trust. We would like to tackle the subject from different perspectives, and in particular to bring together different views from academia and industry for future interoperability. So in one hand, AI is becoming the central drive of innovation in every aspect of industry, and in the other hand, there are legal and tech and ethical challenges related to trustworthiness that needs to be addressed. We will reflect also upon the AI Act and its effectiveness in providing a framework for developing AI applications which are compliant to legal and ethical guidelines. So we would like to answer the main questions like how do we ensure the development of a trustworthy AI system? Do we trust AI application? So before discussing and answering the following question, we will start with a brief introduction from the speakers, giving their views and roadmap on trustworthy AI, and then we will continue with the panel discussion. So Milan, you can proceed introducing the speaker.
Thank you. Thank you, Francesca. So I'm very happy that today we have a very interesting speakers. We have Blaž Fortuna, who is the managing director at QLector, which is a startup company developing AI solutions for manufacturing, logistics, and finance industry. Blaž is also a senior researcher at Joseph Stefan Institute in Slovenia, and he is also initiator and a contributor to QMiner, which is the open source data analytics platform for processing large-scale real-time streams. Blaž did his PhD at the Joseph Stefan Institute and was a research consultant from Bloomberg, and also he was a Marie Curie Fellow at Stanford University. I'm very happy, Blaž, that you're joining us today. Next to Blaž, we have Marcelo Jenka, who is a principal investigator and group leader at EPFL in Switzerland. Before EPFL, Marcelo worked at ETH in Zurich at actually Department of Health Science and Technology. He was also an ordinary member of the Competence of Rehabilitation, Engineering and Science at ETH. Marcelo's research focuses on ethics and governance of biomedical data, ethically aligned artificial intelligence, responsible innovation for emerging technologies, and human-machine interface. He was a principal investigator of interesting projects such as neurotechnology, artificial intelligence, and human rights, or digitizing elderly care, etc. So he has a PhD in biomedical ethics, summa cum laude PhD from University of Basel. So, and what I find also interesting is that Marcelo is co-founder and editor-in-chief of Scienza Live, which is an Italian-speaking web portal that is sort of busy with public understanding of science and technology. So Marcelo, very pleased that you're also joining us today. Finally, we have Arnold Smulders, a professor at University of Amsterdam, who is actually, I know for a very long time, a very known person in the area of computer vision. He was a scientific director of Commit, which was public-private partnership in the Netherlands in the domain of ICT, with 70 partners, budget of more than 100 million euros. So he also is very much involved with the spin-offs and startups. Currently, I think, co-founder of Kepler Vision BV. Finally, Arnold, I know from ADRA, where actually he's on the board of directors, one of the directors of the board, and ADRA is, as you know, the association which was established by BDVA, Eurorobotics, Alex Clare, and Eurorobot and EuroAI to be the private side of the new public-private partnership on AI data and robotics. So. Arnold, I'm very pleased that you're also, thank you for joining us. This session, as Francesca said, we'll organize in a way that we'll have the opening statements from our panel members, and then we will move to the question-answer session. So feel free already to put your questions in the chat, and we will also bring them to the panel members. So, Blaž, we would like to give you the floor for your opening statement. So I understood that you want to share also some slides. Please use screen sharing, and the floor is yours.
Thank you. So thank you, Milan, for the kind introduction. So let me just share my slides. Okay, so I have just for this opening statement, I'd like to share some more like from the use case, some experience. So how do we see how we build trust between the AI application and the stakeholders that are part of the AI application. And to develop this use case, I'll focus on one particular complex system, which is a factory. So if you look at the factory, so everybody kind of has some rough understanding, but actually there's many different layers or systems or silos that are functioning in a factory, which makes it quite complex system and a good ground for developing AI applications. So if we just illustrate what I mean by complex system in a manufacturing plant. So we have many layers ranging from strategy, which are mostly done structured in unstructured documents, going down through sales, through schedules, logistics, human resources, lots of informal knowledge of how to manage all the things down to production lines and machines. And we can use, we can address each level individually with different AI applications, from forecasting to down to anomaly detection. And or we can manage this uniformly, so having kind of developing a digital twin and a model that helps us then make decisions and kind of act. So we have kind of feedback loop. So this is just as a context, and maybe the same thing, but from a different view. Here we have pillars of so Industry 4.0 digital maturity pillars. So there again, we start with very basic things, visibility. So what is happening on the shop floor, for example, this is already covered by existing systems, but as we go on, so why is something happening? Transparency, predictive capacity. So what will happen next, and also adaptability. So being autonomous. This is where AI comes in, and this is where I want to focus on building trust. So if you have a system that predicts how the factory will look like tomorrow, how to manage all the interactions and develop a relationship with the end users around it. So if we focus on how do we typically see these things? So the key is to establishing trust with the end users of the systems. So one of the stakeholders, and there's a big difference between end users and AI practitioners. So we have on one side, we want the end users to develop understanding where AI can excel, so where different areas of AI can help them. And on the other side, we need end users to understand which part of the existing processes, so things that are production or business processes, are easy and which are hard. So this is a non-trivial task usually, and the harder the problem is from an AI perspective, the harder it is to develop trust around it as well. And also it's good to start with the low-hanging fruits to get some quick wins. Also all the stakeholders in the system can see where the benefits are coming from, and also motivates them to give more trust or give them more responsibility to the AI system. So there's one big issue comes from data quality. So each system, the existing IT systems, there are always blind spots. Once you start implementing some prediction, we can see we figure out that there's some data that so far nobody used, or so far it was kind of just somebody done with an email, and kind of covering these blind spots is important, because otherwise we can get very unrealistic results. And also the data integration. So this is also a place where we want to leverage AI methods, so we don't to speed along. And we have to work all the time on building a positive perception. So one way of looking at it is we are building system, we are developing agents that are helping the end users. We are not taking the responsibility, we are not taking tasks from them, but we are making systems that help them be more productive at the end of the day. So one approach is this. If we start for easy start, is to start with decision support. So not going finishing the full loop automatically, but start with providing insights, what we think will happen, and which are the interesting parts the user should pay attention to. And this helps helps at understanding, visualizing how the AI system sees the future. So then the human can the end users can compare this to what they see and slowly see if it aligns or not. If it's not aligned, what can we do to get them aligned? If it's aligned, then this trust relationship starts establishing. We can start being more proactive, so not notifying about business impacting events, and you can also start slowly suggesting what to do to get around things. So kind of having this step-by-step approach to kind of letting the end user slowly release small parts, chunks of responsibility to the AI system. And of course, the end goal is to increase the productivity through automatization, but we have to get there, so we can't just jump in head first. Another part that is quite important is explainability. So it's good that we are able to explain the predictions. It doesn't need to be 100% accurate explanations, but just to see from which part of the history, from which part of, I don't know, training set helped us decide on what we predicted here. Did we see similar events in the past that we can anecdotally help to explain this prediction? Ability to explore the historical data, considering the given prediction. So these kind of things are quite important. One thing that is not often mentioned is traceability of changes. So as the underlying models, the AI system change, keeping track of the differences, what is changing, which part of the data set, the training data or user input, what are the triggers for the updates. So having to see if the end users get used to some kind of reaction of the system, and then next week it's a bit different, you should be able to explain where this difference comes from. And one thing is also that we noticed, it's in the organization you need one or more power users. These are people that can basically come from the domain but are skilled enough in the system that they can kind of debug some of the predictions. So if one employee comes and says, okay, this prediction doesn't make sense, so this power user can go in using all the things that mentioned above and figure out together with the end user why this prediction happened as it is, and is it correct? If not, what can we do to improve it? Maybe just to summarize a couple of challenges. So one is that we need to develop this trust during the implementation, and this phasing of the rollout is quite important. At the end, we must have an impact on business processes. This requires organizational change. We must educate the users on the capabilities so they know what is easy and what is hard. So it's kind of their expectations are aligned. And lastly, it requires discipline. So to keep the blind spots to the minimum, so things don't happen outside the system, because then the system is blind in a sense. That would be all from my side.
Okay, thank you, Blaž.
Thank you, Blaž, for your nice presentation. I'm sure this will be an hint for our panel discussion, so we can continue later discussing about this with addressing question to you. Would like to give the floor to Marcello. Marcello Ianca, the floor is yours. Thank you.
Thank you very much, Francesca, and also thank you very much for having me here. It's a great pleasure and honor to participate in this event. My primary area of research and expertise is AI ethics. So in my input presentation, I would like to provide some general information about the global landscape of AI ethics guidelines, because this is a rapidly evolving area of AI governance where many of the issues relating to trust that we will discuss today are being addressed by both public and private sector actors. And I'm just going to share some information from a published report that I co-wrote with Afi Vallena on behalf of the CAHAI, the Ad Hoc Committee on Artificial Intelligence of the Council of Europe, which in turn is an expanded version of a paper that we published in Nature Machine Intelligence. And in these two documents, we try to provide a review and analysis of the current corpus of AI ethics guidelines. We counted 116, and since then, new ones have been published. And we have seen that most of these guidelines are being developed by governmental agencies, followed by private sector actors, especially those involved in AI development, but also consulting firms and so on. Third, academia, so academic societies, research organizations, and so on. And finally, NGOs. And we have also seen a variation over time in the publication of these documents until 2018. Now it seems that the pace of production is slowing down. We've also observed a very radical disparity in the geographic distribution of these AI ethics guidelines. So this graph shows the frequency of AI ethics guidelines being developed in various parts of the world. And as you see, although AI is a global game, AI ethics and AI governance seem to be a first world game, with the majority of guidelines being developed in Europe, North America, and Japan. And with Global South, especially South America and Africa, being very little involved in this governance effort. I'll summarize some key findings from this analysis we conducted. So one interesting finding in my view is that an increasing number of governmental and non-governmental organizations are developing ethics guidelines or other forms of soft law instruments. And soft law means that is not legally binding. It's persuasive in nature as compared to hard law, which is legally binding. These documents are being primarily developed, as I mentioned, in Europe, North America, and Asia. So there are many regions in the world that are currently underrepresented. And in terms of content, we have seen that these AI ethics guidelines tend to agree on some generic principles, and I'll show you which ones. But they also sharply disagree over the interpretation of these principles and also on the details of what should be done in practice. And we have also seen that no single ethical principle is common to all 116 documents, meaning there is no full consensus. So we found growing agreement around the following ethical principles: transparency, justice, non-maleficence, which means do not harm, so safety principles, responsibility, and privacy. But at the same time, we observe that ethical considerations regarding sustainability, dignity, and solidarity appear significantly underrepresented. And in terms of transparency, which is the #1 principle, we have seen that most guidelines agree that AI should be transparent to avoid potential problems and to build trust, which is relevant to our session. But it does not appear to be clear whether transparency should be achieved through, for example, publishing source code of algorithms, or by making the underlying databases more transparent, or by some other procedural means. We've also seen that slightly more than half of reviewed documents explicitly recommend the promotion of human rights in AI, which is good, but it also means that the remaining half does not make any reference to the promotion of human rights when designing, developing, and deploying AI systems. And then we also run some regular expressions from the codes to reveal significant variations in theme coverage between documents produced within member countries of the Council of Europe and the rest of the world. And it turns out that the documents produced within countries that are members of the Council of Europe emphasize the ethical principles of solidarity, trust, and trustworthiness more than documents produced in the rest of the globe, which seems to suggest that trust and trustworthiness are not necessarily globally unanimous ethical value, but something that we care more about in the European space, largely broadly conceived. So here you have a visual rendering of the frequency of these ethical principles. Trust and trustworthiness, as you see, are here. So they're represented in less than half of the documents. But among those that do refer to trust, interestingly enough, the previous that are more common, such as transparency, fairness, safety, accountability, and privacy, are recognized as key determinants and predictors of trust. So mentioned earlier, so transparency is very common, but it's unclear how transparency should be achieved, for example, through audits and auditability. But some other actors propose different suggestions. Among the principles that are represented, that are cited less often, I think trust is a very good example of an ethical principle that is poorly understood, or at least that is interpreted in many different ways. So we observe that most references to trust include calls for trustworthy AI, such as in the EU framework, or trustworthy AI developers and organizations that should apply trustworthy design principles, or they underline the importance of customers' trust. However, we observe two main conceptual problems. The first one is that these guidelines lack conceptual clarity on the meaning and dynamics of trust. As an ethicist, I like to emphasize that trust is a relational and highly complex concept, which involves at least two actors. One actor trusts the other actor to do or not to do a certain activity. And this relationship is usually among peers. It can hardly be established between humans and AI systems. And it's also influenced by diverse framing factors, such as culture, belief systems, context, and others. So trust is highly situational, and it's very difficult to develop trust as a general concept for AI, in my view. And the second point is that we observed that the trait of trustworthiness and the relational construct of trust are often conflated or used interchangeably in AI ethics guidelines. And this conflation does not only lead to conceptual confusion, at least in my view, but may also foster false hopes among AI users and developers. And to conclude with some final policy implications, we also observed that this soft law instruments are very useful tools. So they are really shaping the way AI is developed and governed internationally, but they exert practical influence on decision making. But at the same time, they should not be considered substitutive of mandatory governance or hard law, because due to the high risk of conflict of interest, these self-regulation efforts by private AI actors are more likely to be exposed to the risk of bypassing governmental or intergovernmental authorities. And then we observe, since geographic distribution was subject to disparity, that there is a need to ensure more inclusiveness and cultural pluralism and fair participation to collective decision-making on AI. And I think this could be a key prerequisite to build trust in the AI industry at the global level. And finally, that the convergence of soft law instruments around certain ethical principles such as transparency, justice, non-maleficence, responsibility, and privacy identify possible areas of oversight that should be developed by further governance. And one final note, it's on the importance to clarify this concept. So I mentioned earlier the semantic ambiguities that need to be resolved, and trust in particular is a key example of this. If we avoid this kind of conceptual clarification or clarification on the interpretation of trust, then we may develop solutions that are likely subject to public disagreement, hence will require a higher degree of transparency in the democratic deliberation process. And finally, the underrepresented ethical considerations need to be further scrutinized to avoid importing into future governance the same gaps and normative blind spots of current AI ethics and soft law. Thank you very much.
Thank you, Marcello. So now we heard actually the view from Blaž with the perspective of a startup company. We heard Marcello who gave us perspective from the someone who works on ethics. Now I would like to invite you, Arnold, to give us your perspective. I assume very much perspective from the research point of view.
Let me see here. Is that all right? Do you see the screen properly?
Yes.
I think this is scientifically, this is a very interesting topic, because other than most science topic is not under your complete control, what we are discussing today. So that's why it's very interesting. I've brought the work of two of my students with me, and I'm representing here also the ALICE, that is the Network of Excellence in Research in AI, read machine learning. Okay, so the first question I would like to put on the table is, do you have a dentist, and are you satisfied with the dentist? And let's assume the answer is yes. Good for you, congratulations. But now the question is, how do you know? And there is, I once thought in my life I had a very good dentist, because he didn't say very much, and he was just doing his work. And it was an old man with gray hair. And then I went to the next dentist who was young, and they said, and to my surprise, he said, well, that is rubbish, we all have to replace it. So, okay, so this is a tale of fear and trust. I could have also taken the example of how do you know your vaccine is good, but that's maybe a little bit too hot to discuss today. So keep in mind, why do you trust your dentist? Because that's, well, maybe because he's predictable. If it's a he, actually, it could also be a she, of course. He's respectable in his general behavior. He is limited in the sense of he doesn't sell you flowers while being a dentist. He's prepared to communicate. So this is, in general, the way trust is built. And now trust is a very interesting property, as already discussed before, because it's not an engineering problem. You cannot set a goal and then you do 5 steps and then you have it. It's essentially a voluntary consent from the other side. So you can behave in a certain way and then hope that on the other side trust will build, but that's about it. Okay, let's translate this to AI. Most important aspect of trust is that it is producing predicted results. In other words, the robustness. And not only the robustness in general, or the performance in general, but also when the circumstances are a bit off. You all remember these photographs where people were classified as a monkey and reverse, and that immediately took away all the confidence in this dentist, right? And the same holds for, do you have a reasonable explanation? We get back to that. We get, do you only consider this, or do you drag in something else? Is the limits of the request, the limits of the control, and the fairness. I will focus for my own research on the first two, but also discuss the later three. Okay, so the robustness is done when the model is not ideal. In other words, there is something, there is some form of disturbance. There is a famous one. It's called adversarial. It was a sensation in research. And by the way, for our purposes, it's practically useless. We've recently demonstrated if you do adversarial training, that is, you add a little bit of noise to such a degree that our image hardly changes, then you can have all sorts of wrong results. Well, good for you, but this is almost a deliberate takeout, which will rarely occur because the training images, very few people have access to do this deliberately. It could be, but that's extremely rare. And if you use adversarial training, like you feed these images with maximally optimized noise to get it off the rails, then it has no predictability on or no influence on the other real life disturbances as you show, as are shown in the bottom: Gaussian noise, shot noise, snow, motion blur, JPEG algorithm, brightness changes or deformations. None of this will sail comfortably through the adversarial training procedure. So it has, it's interesting to watch that only a little bit of carefully designed noise takes the machine algorithm off the rails, but for general purpose goals, where I have patterns in the deviation, that doesn't help at all. And this is taken from a reference where they've collected all sorts of natural noises. Okay, so what did we do? We took these types of known perturbations or common perturbations, like elastic transforms or local shot noise, which obscures the details of the image. And in the first run, we transformed the data and offer that also to the system. And then we concluded, well, you can make a system robust at the loss of very little of its performance. And but it's still, after that, much more robust, even to causes you have not trained it for. So that helps. And the second very recent step, it's now under review. So I can't tell you all about it, but I give you in the bottom part of the image, I give you one glimpse of what the method looks like. You take the weights in the algorithm, you deform them a bit, and then if you train with the standard images you have, it will be much more robust in general and even sometimes improve the original classification. So that's really what you want to do. So now you have, by taking a little bit care, you've made the machine learning algorithm more robust. I hope that the latter method is already available on arXiv, so you can read it. But I hope that it will be published, say, a few months from now. Okay, and the second step, as we considered earlier, don't focus too much on performance. Typically, 95% of all machine learning people are focusing on optimizing the performance. You can't blame them because that's their engineering task. But in practice, it's much more important to not super optimize the performance, but to explain what you do. Now, there is a stream of thoughts where you say, well, the only reasonable explanation is by giving rules. I've done it like this. Basically, what a general practitioner do to you. You have a flu because, and then comes maximally 5 reasons, and you go home satisfied because you've understood it. But a radiology person does not do it. He doesn't explain it to you. You have to believe her, or if you don't, she will point at you in the photograph, this is wrong, and this is wrong, and this is wrong. In other words, she does visualization. So depending on the situation, there are several styles of explanation, not necessarily only by text. And typically, the training of, for instance, in internal medicine is done by showing the most similar example from the archive, right? So that's another typical way of explanation. Okay, we've done also research there. So rather than going for a full force machine learning, we first did attribute classification to see what type of bird this was. So for instance, this is a cardinal bird. And why is it a cardinal? Because it's red, but it's not the only one who has red. He has also a red, how do you call this? I don't know the English word, but it was in fashion for a while in the Netherlands that you would have your hair like this. And now if you disturb it, it could classify it in the wrong class, but we can now explain it, because if this is not there, it's not seen, we can explain that that's the reason why it is in another class. And the people in the multimedia retrieval community liked this paper very much. It's 2 years old. Okay. Privacy. Privacy is a very critical notion, and I think it's getting more and more in the field of attention. And the people in Europe think that it's their topic, but I can assure you in the US, it is also very well studied these days. And here, you remember the issue a few years ago. It was found out that cars would send their data to the manufacturer. And the assurance from the car manufacturer, he came from Germany, but that's not a big guess, of course, because all cars come from Germany. I won't tell you which one, doesn't matter. The answer of the engineering department was, no, don't worry, please, don't worry, public, because it's all anonymous, okay? So I've showed you here on the map, the data sent to the manufacturer for my car. Now I have, it's totally anonymous. Now I have a few questions for you. Where do I live? Where do I work? Who is my secret girlfriend? How often do I go and visit my mother? Well, the last two is not entirely clear, because they can be changed, whether depending on which one I like most, but nevertheless, it is clear, right? There is nothing about anonymity at all. It's not sufficient. And differential privacy chops these black lines of one single route into parts, combines it with other parts from other cars, and then statistically you can't trace it back or reconstruct it to who it was, and you still can find general conclusions, like many people go from this part to this part by correlation. That's differential privacy for you. It's a non-trivial part of current machine learning, so to say. That's one solution. There are other solutions, but this is one. Okay. Now controllability. We go back to the dentist. I trust my dentist because he behaves at what I give to him, my dossier and my teeth, he treats carefully. And this will be the most, I believe, the most persistent in the public awareness of AI. That It's building and building slowly but steadily. My biggest worry about AI is the accumulation, the unnecessary accumulation of all sorts of data given in the hand of nerds, right? If you assume that I'm a nerd too, then you trust me in my statement. Why would nerds own access to the private data of half of the world population? There is no need for it. And this is fundamentally an issue to solve within 10 years from now. So algorithms would fundamentally be redesigned to travel to the data rather than that the data travel to the algorithm. And it would, and when it arrives at the data, it should have trusted entrance. For instance, there is a famous researcher in the Netherlands, Bart Jacobs, who designed the IRMA principle, which is I relieve my attribute. And rather than answering cookie questions, which basically is the access to everything, especially and made in such a way that it is very hard to always do. The IRMA principle takes the other stance. It says I put a gate around my data and I let you in for the purpose I want. Also non-trivial, but I wanted to bring it up for the discussion later on. And then finally, fairness. In your lifetime, you remember maybe this. 5 years ago, 4 years ago, when you typed in the question, 3 white guys, you would get one of these photographs back. And when you typed in 3 black guys, you get the other photograph back. And yes, you could say, well, I'm a technology company, so you raise the query, I've answered them. But it was a big issue that to the left, there are 3 guys from prison, and to the right, there are 3 guys from the beach. And the answer, well, the problem is in the data we learn from, so it is a societal problem, not our problem. That's the initial answer by Google. That's completely true, but it's no excuse. So you have to make it fair before you launch a public service. And that's completely non-trivial, and by now it's no longer valid. But I give you another example, which is valid until a week ago, at least. I searched for a male patient of a dentist on the internet. I hardly couldn't find it. There was exactly one instance. All other 199 images were of female patients. So Google may have solved this problem, but not the general problem. Let me put it that way. That's what I wanted to say for introduction. Thank you.
Thanks, Arnold. It was a very nice presentation. Yeah, as Milan said at the beginning and also before this presentation, we have now 3 different views from industry, research, and ethics. And yeah, maybe we can deepen a bit the interoperability and the difference in views and perspectives with our panel discussion. So I would like to introduce and start with this panel. And the first question that I would like to pick to introduce this panel is a question that I would like to address to Blaž. And just to summarize what you have already presented and to give your view and start with a discussion that can, of course, continue by picking some questions from the audience. I also invite the audience to ask some questions. I would ask, so Blaž, do we trust AI applications?
Maybe one view is that most of the time that we actually interact with AI with any form, we don't really realize that, or most people don't realize. So it's already going on, I don't know, on Facebook, deciding what you see or the ads you get. All these kind of things are kind of there, but I think not many people actually go and think how did this think, what is the all the kind of amazing technology at the back that makes this little ad appear here and show it what it shows. And also that's one. So I think most of the time I don't really know. So it's hard to talk about trust in that relationship. It's just there. On the examples where people are explicitly aware they are working with, interacting with some kind of more maybe fuzzy system. So it's more, so there's some machine learning at the back, there's some prediction at the back. I think it's the default. You have two camps. One is that's what the machine says. Okay, that must be like that. I mean, I don't, and it's kind of also offloading the responsibility. And the other one is also very kind of suspicious. So having more thoughtful look. So thinking whether this number, maybe it says this, but maybe I should just hide up a little bit to the default, because it's at the end it's on me who is has to submit this report forward to the purchasing. So it's. I think it depends very much on the person, and it's most of the time we are not really aware of that we are actually interacting with an AI application.
Yeah, perhaps it's maybe good also. I think Arnold, you had an interesting examples with respect to this. Do we really trust AI and with dentists, etc. So, and I think, I mean, all of us, we are professionals, and all of us, we try to do our job perfectly. Yeah? So someone is more perfectionist than the other, but everyone tries to do as less mistakes as possible. And we know that AI, on the other hand, comes with these performance measures, and that it's not all the time accurate. So does it make a real difference then how we actually should try to enable trust to AI? I mean, you were talking a bit about, Arnold, I was pointing to you because you were talking a bit about like whether we should focus on ensuring performance and ensure that basically this AI is really performant and all the time accurate, or we should try to put more focus on explaining why sometimes it's not accurate.
I would say the following. For some of the systems Blas described, you can take a rope and circle around the problem and completely close it. And if that is the case, when it's a completely closed problem, you can optimize it as we engineers do. Nothing to worry about. And when systems are a tiny bit open, and a dentist is almost closed, but not exactly, right? So now we are focusing on what is the not open component. And then trust is we cannot engineer anymore because we only can hope for it. And then comes in the things like, well, it may be technically perfectly perfect that you come up with a criterion Blas and the classification error or Kullback-Leitner divergence has been minimalized. Well, if I hear this and I'm a member of the public, I have no clue what so I have my own interpretation of it. And so I think that the first thing you do when you move to not entirely closed systems, and the dentist is already somewhat open, is to verify whether the perception on the other side is identical to yours. That if you say, well, I did my honest best, but I I optimized the minimum classification error, then does the other side then perceive that as the identical point? And that's basically when robustness comes in, because the general public assumes that if you solve this problem, then the very close next problem you've also solved. And I've never seen a situation where if you can make the table for 5 people, why can't you make it for 6? Yeah, because it was not in the engineering problem. Yeah, sorry. Yeah. So, and that's the weak point of AI, that the generalization to even the slightest or standard deviations, and that's why we study robustness. But what we study is only the first step of robustness, common deteriorations, but common generalizations I know very little work of. So there is some, for closed systems, we all agree, right? And that's not the problem, and they should be, and the fear of the public and parliament on AI should there evaporate as soon as possible. But for open or half open or narrowly open systems, this is, for what I believe, the way to go.
And Arnold, does that mean actually then, let me just be provocative, that before we don't solve the problem of general AI, that we will not get trust into the applications that are not closed but open?
Well, there's also a practical point of view, and that if I'm in favor of driving a car on the highway automatically, because it's provenly better than if you do it by person. I'm against driving a car in the city because you can't trust it. But on the highway, this task, and so I don't believe that it's necessary to solve the general AI problem first, but I believe it is reasonable to think of the set of, does it generalize a bit? Does it, is it robust a bit? Is it, and to demonstrate these points into the conversation with the public, and think, trust from the public way of thinking, not from the engineering way of thinking.
Thank you. I think that's interesting. I don't know, Marcello, whether you want to add anything to this discussion from the ethical perspective.
Well, maybe going back to the question about whether we are trusting AI systems, I can translate this question into an ethical question, which is, should we trust AI systems? Because I think this is a very popular question in AI ethics and policy. Notably, as many people in the audience know, the European Commission's high-level expert group on AI has adopted the position that we should establish a relationship of trust with AI. But as I tried to mention in my email, in my input presentation, I'm quite skeptical that this is actually possible, because trust is a relationship between peers, and most importantly, it's a relationship between agents. You need to have agency in order to trust somebody and be trusted by somebody. And AI today does not have agency. Which does not mean it will never have agency. It will most likely will at some point, but then we should ask ourselves the question about whether it is desirable to have AI systems that have agency, and therefore to systems to which we can attribute more responsibilities. And I have a personal skepticism from an ethical perspective, that considering AI as peers with humans, and therefore is capable of establishing a trust relationship with us, is actually desirable. I think it can actually create ethical and legal ambiguities. In particular, I think it is essential that AI systems are never presented as morally responsible or legally liable in and of themselves, because moral responsibility and legal liability are based on human characteristics, such as being accountable in front of the law, and having the ability to suffer, being entitled to certain freedoms and fundamental rights, and so on. So when we translate this into AI systems, we may have some interesting ambiguities. Many people have argued, for example, Joanna Bryson, that considering AI systems as legal persons will be the ultimate shell company, right? Because then it will be very easy for human actors, including tech companies and so on, to outsource their responsibilities and liabilities to the imprescriptibility of algorithms. And then if people are not responsible and they outsource responsibility to algorithms, then nobody is responsible, most likely. And this is a concern I share.
Yeah, indeed. No, thank you. Maybe going to a bit of like discussion with respect to the development of trustworthy AI systems. Arnold, you mentioned privacy as a sort of concern, and then by answering the last question, you were saying like, okay, there are these people that are developing the algorithms and these people that are using the algorithms, and obviously. We discussed that it's really important to understand the performance of these algorithms after the deployment. So we need to understand whether they are doing well or not, and to ensure that we can, build trust and ensure there is trust. So on one hand, we need more data because we need to understand actually also how they are used and what's going on. On the other hand, there is this privacy concern, and then you were talking a bit about also. Sending the algorithms to data. So perhaps maybe you can address this bigger question about the ensuring the trustworthiness during the development, but then also maybe address the point like how we deal with this. And then if you want, for example, to send the algorithms to data, how we ensure quality, because I mean, then the guys that are developing algorithms, they don't see the data. They don't know whether the data is good, but data is actually the fuel for the algorithm. So if the data is not good and not of a good quality, then the algorithms will be of bad quality, and then we'll end up with systems that are actually not trustworthy because they are not having good performance. So how do you see this?
There's no fundamental solution other than what already exists in practice. So let's imagine a medical imaging company somewhere in the southern part of the Netherlands, and they want to design a good algorithm, a good predictive algorithm. What do? They collect data, and usually they go to certain academic hospitals to acquire them. Now, this is a current practice, and you could easily find an AI machine learning equivalent for that. Effectively, it already exists. But AI opens also more doors. For instance, if the disease is very rare, then you couldn't do it this way because it would take too long to acquire the data. So either you go to patient-related associations, or you try to collect rare data. And in the end, and rare data, but then of course you have to build trust, so it has to be sure that the data you use will not be wind up in public, but will wind up and be trusted to share. Almost every patient of a rare disease will be happy to do so, but it has to be absolutely certain that it's only for one purpose and for one purpose only, namely to find out more about the disease. So, and in the end, you could say, well, if medicine progresses far enough, then every disease is rare, because we want to personalize the treatment to the individual qualities of one person. So the future is for the algorithm to travel to the data, and the data to be sufficiently protected. The current practice, I don't have to tell you, is in the social media domain, is completely different, and that ruins also the political viability of the previous scenario I painted. Because the political debate in the Euro Parliament is dominated by the practice of the social media. In times of COVID, I went to a terrace. I couldn't pay with coins. I had to pay with electronic means. So as I always do, I checked for one moment the app I had to download in order to be able to pay. We're talking about one espresso, so this was €2.20, and there were 75 companies who were sending cookies to my telephone, which were keeping the data between 2 months and 7 years. They didn't say in their what they were acquiring. I don't think it was only 220 they were acquiring, but that's a pretty useless number and not even a prime number. Yeah, so it is this is really 10 years from now, we will look back at this period as how has it ever been possible? That's not reasonable for a free app to pay in a restaurant for 75 companies to acquire data from my telephone for between up to 7 years, right? And but this is the current operational scheme, Milan. I think that, and it will not be easy to get at the table with the every disease is rare, and you would acquire a trustworthy scheme because you're combating the other way of doing. Nevertheless, I'm firmly believe that the other scheme of acquiring all data I can grab will end. It will not go on between now and 5 years. There will be a serious decline, and maybe 10 years from now it's gone, because it's unsustainable. And interestingly enough, in the European Parliament as a whole, not necessarily the most advanced institutions of the world, they have accepted a motion. It's meaningless at this point because it's only a desire. Last year, that the acquisition of data from for the purpose of personal advertising should be forbidden. This is the first motion I know of from the European Parliament where they express insight into the mechanisms of the new technology and how they could intervene with that. But that motion is accepted, has been accepted, right? So that, but so we have to sort out, as always. You can't blame the public that they see these two types of AI use as all as one. But so it will take a lot of personal communication before it's separated, and we can easily, from the words of Blas, we can easily formulate another use of AI, namely when it's completely closed application. Why do we need this at all? Yeah, there is no real reason for it.
Yeah, and maybe that's a good moment to actually ask you, Blaž, how you see this with respect to the development of trustworthy AI systems in Industry 4.0. Is this privacy concern there a concern, or do you also see actually possibility to have this federated learning, or where basically we send algorithms to data, or you see other approaches there?
Yes, so the industry, it's very interesting. So manufacturing is very interesting from the perspective. So on one side there, when you're with whichever applications you're doing there, it's always the data that you have access is kind of core company data. So having so it's not medical, it's not the same as medical data, but still companies are careful about how they share, who sees the data and so on. And also once models that are built out of the data kind of capture. So just by observing, looking at the models you can see how the company functions. So just the models itself capture a lot of know-how and a lot of kind of internal kind of secrets.
So how you deal with this then? Do your customer actually trust your company that you would actually be properly taking care of this data, or you would apply certain privacy technologies, privacy enhancing technologies to deal with it?
Yeah, so we have to be very careful just where to draw firewalls to where particular data goes, what is extracted, what is sent where. And also we have, it's quite strict with respect to security protocols and everything. So you need to have all the ISO security standards and so on that, for companies to be willing to jump on board. And the second thing is also that kind of interesting from here is that most of the AI, I mean, most of lots of stuff is happening on the cloud, and for companies that are used to having everything on premise, have sending data to the cloud where it's kind of out of reach is also a big leap of faith in that sense. So there's a trust. It's independent of AI, but it's another level of trust they must have into that their data will be handled correctly by the external parties. There's another part of trustworthy is also there are tasks. So you have a very well-defined problem. So this was very nice analogy with putting a rope around. So kind of vision for quality control is very nice. You put the camera in front of the product, it checks, it says everything is there, parts are missing. So kind of well-defined, easy. If something is wrong, we can go back and check the picture and see where we were wrong. And then as you go a bit further down, it gets, so if you come to already predictive maintenance, which is still on a machine level, saying, now this machine replace this part because otherwise in 4 weeks you have a very high likelihood of a breakdown. So there's some level of trust between the vendor and the customer. So where do we put the thresholds? How did we went for precision or we went for recall? Do we, are we just want to, by increasing the threshold there, basically we can generate extra revenue with more parts. So it's a different type of trust, but it's there. So it's not.
So that's interesting. Yeah. And do you have experience with for example, federated learning? How would if you have in your company a data scientist, how data scientist would feel himself like to trust that actually, without seeing the data itself, that the algorithms that he would send to the customer, that actually these algorithms will create good models at the end. So without seeing,
even for federated learning, you need some form of feedback loops or some level of customers being able to report what is happening and getting some access to the system on the time when it's doing a mistake. So there must be protocols in place for that, because it's a big step to run something somewhere, especially with vision. It's just having local environment. Is it day? Is it night? Maybe the bulbs start blinking. It's so many things that can go wrong that it's it's quite hard from the data science point of view. So in theory, it's quite nice, but there's somebody put a bottle in front of the sensor or something like that. It's lots of these little things that no model. I mean, it's hard in a model to account for, and if you're so having this good control of the data is important, and also having a good control or a feedback loop for the end users to communicate back the errors, so it can be debugged.
Yeah, the one thing, because to connect also with the presentation of Arnold, is for instance explainability, giving added value to trustworthy, for instance, also in federated learning, and how we can combine model explainability with model confidence to give to the user a score of a trust in the trustworthy AI system. Do you see some connection here, Arnold and Blaž, explainability and confidence for improving trust?
So maybe I can go first. So this, I think explainability for sure it's very important, at least from from my experience with talking to the end customers. Once you have the initial numbers or predictions or whatever, it's nice, but or like this example that Arnold mentioned, driving on the autonomous driving on a highway. So it's if you would look on a on a one year period, number of mistakes a person would make or a computer would make, for sure computer would be, I think in these control settings would be more efficient. But once it does one mistake, everybody says, but I wouldn't, if I would be holding the wheel, I wouldn't be doing this. And it's at that moment, it's very easy to lose the trust. So this robustness or kind of having ability to communicate this confidence in the decision also helps in establishing the trust. So, and it shows that there are parts where the algorithm is more confident, part that is less confident. So we have these dynamics there as well. It's not only yes or no.
Thank you. And which is your view, Arnold? You mentioned explainability, but you see an opportunity to combine explainability and confidence to give trust to the user somehow?
Yeah. Well,
also in a quantitative point of view, like giving a quantitative, yeah.
One of the lessons I've learned from COVID is how incredibly difficult it is to bring across probabilities. Even for the masses of people in the Netherlands who have had a statistics course, still don't understand probabilities when it's in the real world, because they prefer much more clearness, so to say. So I would say that you can broadcast a posteriori probabilities, and they're easy to calculate. But I would be, for almost any application, it would be very good to verify whether the message had come across. That holds for in the medical profession. That holds in almost any profession. So for me, a posteriori probabilities, I'm not against it. It's useful, but it is still from the broadcasting point of view and not necessarily from the reception point of view. That would be my point there.
And how we didn't discuss. There was an interesting question from the audience from Anna Ortega Gil about the value of validation and in building trust, because I remember that many times, in healthcare also, for example, a radiologist would use MR machine and then would basically look at the images of the MR machine and would trust these images without understanding actually how this machine really works, because it's very complex machine with helium, with all the magnets, etc. So, and they still trust because it's validated. It has been shown in the past that it works very well. So, what is your view on AI and validation of AI algorithms?
Marcelo?
Okay, I can get started with this question. Well, I think it's a very valid one. It's a very good question. I'll probably partly reiterate what I mentioned earlier. So I'm still skeptical that trust is the right word here, but I think we have a better word for defining the relationship between humans and machines, and that's reliability. And reliability is based on a statistical expectation that a certain system X will fulfill a task Y in the way that we instruct the system to do. And I think from this point of view, validating AI systems is a key prerequisite for reliability, right? So we can only have a system to which we can attribute reliability if it's adequately validated. And then there is a separate question, which is what kind of validation, because sometimes we can have, proof of concept validation that works in an experimental setting, but then once we deploy the system in the real world, that system does not perform in the way that we expected. So we need to have a broad concept of validation. So one area that I'm very interested in is AI in healthcare, since I mostly work on medical applications. And in healthcare, you can really make the comparison between technology-based intervention and known interventions that are not based on technology. And for pharmaceuticals, for example, we have very strict requirements that we've been developing over time. We have clinical trials and we have double-blind studies and so on. We do not have exactly the same validation standards for AI. So maybe we should develop those validation standards, have a broad concept of validation that goes beyond the experimental setting and involves also real real-world validation. And I think once we have adequate validation, we will have reliable systems, which is a prerequisite not for trusting AI systems per se, but for making the public trust the AI industry, which I think is a really important question that we should ask ourselves.
Milan, can I ask Marcelo a question, which intrigues me? So you wonder why AI, before it is even used on a massive scale, has already for quite some years public scrutiny, right? That if you look surely in the Euro Parliament, but also in the Dutch Parliament, whereas there are many things introduced in life, like nanotechnology, is virtually without any scrutiny at all, right? And the question is, why is that the case fundamentally?
I'm not sure I can respond on behalf of the European Parliament or any other institution. I think the reason why there is a lot of public policy interest in AI is twofold. There is a good and a bad reason. The bad reason is that I think that the AI industry is substantively hyped. And policymakers are just following the hype. Instead of deflating the bubble, they are reinflating the hype bubble. On the other hand, I think there is a good reason, which is what we call proactive or anticipatory governance. So you cannot regulate a technology only in a reactive way. So you wait until something bad happens or certain bad societal outcomes unfold, and then you react to that because it's typically too late. There is a famous adagio we use in technology assessment studies that says that it's always too early to assess a technology until it's suddenly too late. So I think it's very important to combine reactive approaches with proactive ones. So we need to anticipate the implications and the impact that AI systems will have on human societies. And sometimes, starting early enough is not a bad idea, as long as we do this in an evidence-based manner, rather than relying on pure hypotheticals or speculations. I think we need to do what we call in our field adaptive governance. So a governance that adapts to a situations of uncertainty and is based on scientific evidence and is willing to change governance paradigms as we get more evidence or as our evidence changes over time.
And perhaps maybe also good to discuss trust in AI. We were discussing this topic, and now Arnold is also putting another topic at the table. Does that actually have to do with maybe potential of AI or maybe fears that people have? Because we often say, okay, if we keep AI under control, then AI can work for us as a human race, and if we lose control, then maybe that's the next step in evolution. So how you see that? Arnold, maybe you can answer this. Huh?
So in hindsight, you could wonder whether broadcasting that the world champion chess was beaten by a computer has been a bad thing in the history of AI. Because you can surely bet that it induced fear into many hearts. And the same, my father grew up in a time he had his driver's license at age 14 because there were only a limited number of cars. And if he would now hear that the next generation cars would have no chauffeur, his heart would be broken, so to say. Yeah? And so this invasion into typically things you have acquired to learn in your lifetime is one of the most fear-propelling things. And then it starts. We're old enough, Milan, that we've come in hospitals all our professional life, and the answer I had to answer most is, in all those 40 years, is when are you going to make me jobless? Which is totally ludicrous. And never was my intention, nor of Philips, or not of the government. Yeah, but so that's why the more I view of this, the more we should downplay what AI really can, not realistically, but so the world chess player algorithm can only do world chess. It cannot do the dishes. It cannot even
anything else.
Presumably pass an exam. It can do nothing of all of this, right?
Yeah. No, thank you. Anything from you, Marcello, or Blaž?
Yeah, no, I agree with Arnold, and I also think that it is very important to consider this question within the right time frame, because in order for AI to become uncontrollable, so for humans to lose control over AI, then AI needs to outsmart humans. And I'm not among those who think this is logically impossible. I think there's nothing magic in the human brain that cannot be replicated in silico. But this is really a long-term scenario. So I would be worrying about this to the same extent that I would be worrying about overpopulation on Mars. Maybe at some point eventually this will become a concrete problem, but it's not something that doesn't make me sleep at night today. But at the same time, I think there is a ancillary question that we should ask ourselves. It's not about what happens if AI becomes evil, but what happens if other humans use AI in an evil way? And I think this is a very concrete question for policy and governance. You don't need to have a particularly intelligent technology in order to have a negative impact on societies. Look at social media, for example. There are pretty dumb platforms, but within the space of time of 15 years, they managed to reshape completely our notion of privacy and to influence political deliberation across the globe. So even technologies that are not particularly sophisticated can have a major impact if they're used in a certain manner. And I think the task of policy governance, but also of us as researchers, because we have a societal responsibility, is to try to anticipate these scenarios and align AI development with desirable goals.
Thanks. Francesca, are there other questions perhaps that maybe I think we are 7 minutes to go. Perhaps maybe there is one more question that we can try to address.
Yeah, one interesting question would be to address the new AI Act and its impact on AI technology. Maybe both Arnold or Blaž, or Marcello, if you are aware of that. Maybe one question would be, which is the balance between innovation and regulations with respect to trustworthy AI in the new AI Act?
Well, let Marcello go first.
Oh, please do. I've been talking enough.
No. Well, okay. It's interesting to have read the new AI Act, and 304 people have filed an official reaction to it. So they have quite something to study. What I think is fundamentally wrong is the fact that AI is defined in the law, because it should not focus on AI. It should focus on anything and then be reasonable there. And why is that the case? Because if I were a lawyer at, say, Facebook, I know exactly what to do. As soon as this law is passed into law, then I would start a debate at the courts of what is AI. And this could easily drag on for a year, 13 years or so. So it has no effective power the way it is set up because there is a boundary in the law. And on the other hand, I firmly believe that it's reasonable to regulate at least something. And these, there are 6 very critical things mentioned. I'm expecting that when it passes to Parliament, 6 will be expanded to 8, or there will be another category and so on. So you can, so this is a sort of, and before the people will sleep bad because of what I say, your opening doors, you don't understand, and this is all very intermediary into what is really needed. And the really needed thing is to put the only thing which is accountable, the people who make this, into a mood that they produce responsible results. And with the proper intentions and proper care. That's basically everything that is needed at this point. And if the law doesn't make a very clear and built-in division of the types of AI systems we've seen at this table, when it's completely closed, why is a law needed? When it is for an idealistic purpose, like rare disease, all diseases are rare, there has to be another intent than when it is for deriving new businesses from privacy robbed and politically motivated social media use. So this is an intermediate law which will not last very long when it even gets to the point of being taken. And there are all sorts of opportunity to make it worse. Yeah, so.
Thank you. Maybe Marcello?
I agree. I generally agree. I should probably say up front, that we also have to try to be charitable, because this is a first of its kind legal framework on AI. So every new thing has its pros and cons. And when you have to invent something from scratch, it's very easy to make mistakes. And I do think that the current AI Act is establishing a regime that is both over-regulating and under-regulating at the same time. I think it's largely over-regulating beneficial AI applications in fields such as healthcare and transportation and many others, by creating a framework that is too heavy and too rigid, not sufficiently agile to address these challenges. And sometimes there are cases where it's under-regulating when it comes, for example, to face recognition for national security purposes, so by law enforcement agencies. So I totally agree that there is a lot of room for improvement, but I want to take a charitable take and think that it's an attempt and more work will be done.
Fair enough. Yeah. And as I said before, one of my greatest dangers is data accumulation. Unreasonable accumulation is not treated yet. But okay.
And I think that this data, the data actually issue is maybe even something not related to AI. Obviously, we say yes, data we need for AI, but very often actually companies or others are collecting the data not for the reason of AI. As we are approaching actually the top of the hour, 1 minute to go, so I would like to take the opportunity to thank you, Arnold, Blaž, Marcello, for joining this panel. I would also like to thank the audience for listening. Obviously, there is a lot of opportunities for each of us to work on. We heard opportunities with respect to policy. We heard opportunities with respect to research, as well as industry to apply and build trust with the customers. So great way forward. So thank you again for joining this panel session, and enjoy the rest of the day.
Thank you, everyone.
Thank you.
Thank you.
Thank you. Bye.
Jessica, for chairing the session.
Thank you.
Thank you.
Okay, we are live and welcome to the session on hybrid AI in the European Big Data Value Forum 21. So this session is called How Knowledge Models Are Essential for Trustworthy AI. My name is Freek Bomhoff. I am a consultant at TNO, which is the Dutch research organization for applied research. And we have a number of interesting speakers in this session, and I will briefly introduce them to you. The first is one of my colleagues, Tommaso Manucci. Tommaso, he is working as a researcher on applications of autonomous systems and how to use machine learning in these autonomous systems. He has primarily worked with unmanned aerial systems, but he's now working on ground-based systems, as you will see in his presentation. We then have Professor Paolo Giudici of the University of Pavia, who is a professor of statistics and risk management at the universities there. And he is very much involved in various Horizon projects, also member of various editorial boards and steering committees. So you will find his name everywhere as long as you are looking into the financial sector and the usage of data intensive systems there, primarily related to statistics and risk management. And lastly, we have Christian Müller of DFKI, the German research organization on artificial intelligence. He is the head of the Component Center of Autonomous Driving at DFKI. And there he is focusing on AI technology as a part of sensor-based environment perception and also trajectory planning, and also in general, how artificial drivers, how autonomous vehicles are behaving on the road. Dr. Müller has not yet joined us, so he is probably delayed a little bit, but he will join in later in this session, and he's conveniently scheduled towards the end of the session. This session is scheduled to last until 5:30. So that means every speaker has roughly 30 minutes, and we expect that the presentation itself will be somewhere between 15-25 minutes, leaving room for interactions from the audience. You can use the chat window to ask your questions, and then I will act as a moderator and pick the questions and forward them to the speakers. And at the end of the session, when there is time left, we can have also a more general interaction with all of the speakers and to look back at what we've learned on this rather, well, some say old-fashioned way of doing AI. Everybody knows that AI has reached far and very interesting results in the recently because of the abundance of data that is available and with the usage of recent developments like deep learning. But many AI researchers have come to the conclusion that there is a limit, an upper limit to what you can reach with a data-only approach. And that is why many people have started to shift their attention to also what is called the good old-fashioned AI, based on knowledge rules, knowledge models, and how to effectively integrate them with data-driven approaches. And we believe that this hybrid AI, both knowledge-driven and data-driven, hybrid AI is really one of the fundamental technologies that is needed if you want to reach trustworthy AI, as we like to reach within the European Union, and also complying with the proposed AI regulation. So we hope to give you some insight into our into some recent developments and some plans that we are about to carry out that all involve hybrid AI and that are all aimed at reaching trustworthy AI systems. So without much further ado, I would like to invite Dr. Tommaso Manucci to the floor and ask him to share with us what they have done with hybrid AI in the context of autonomous systems. Tommaso, the floor is yours. You can share your screen.
Thank you very much, Freek. I will indeed share the screen as soon as I can do that. Should be able to see my screen at the moment. Freek, can you confirm?
Yeah.
Okay. Well, first of all, let's go back. First of all, welcome everyone. I'm very pleased of being here and thank you for the introduction. Indeed, my topic today would be on trustworthy robotic search missions via hybrid AI planning. So trustworthy is right in the title. And I would like to show you how hybrid AI can be a very powerful tool to gain trustworthiness in autonomous systems, whether they are robotic or not. First, I would like to just mention what here at the TNO we consider some of the most important challenges for AI in, let's say, moving from current AI application to future AI application. And we see actually 4 different, let's say, dimensions. We have a dimension of purpose, so moving from single purpose to multiple purpose AI. We have the dimension of environment, moving from a more controlled, organized environment to a more open environment, moving from, let's say, low risk applications to high risk applications, and finally moving from, let's say, standalone AI to collaborative AI, which might even involve humans. And looking about the challenge of moving to a more open environment, this is where our the project of which we talk today is situated, Project Snow. And this Snow is a, let's say, afkorting, a shortening of the sentence safe autonomous systems in an open world. And specifically, the one challenge that we're trying to tackle with this project is how to reduce the number of operator interventions, so the number of time that humans have to actually intervene during autonomous missions. We know that for remotely controlled systems, this complexity, increasing the complexity of the environment, there would be an increase in interventions. What we're trying to do with Snow, as you can see from let me get the pointer actually, as you can see from this graphic, we want to reduce the number of interventions, and we also want to reduce the increase in interventions with the increasing complexity of the environment for autonomous systems. How we do that? Well, we have an approach in mind, of course, which at its core has both hybrid AI and awareness, making the system as aware as we can do it. Both aware of its situation, so achieving situation awareness, recognizing new objects, for example. User awareness, so the system should be aware of what its goal should be, what the preferences for its course of actions are, but also self-awareness, meaning with that, having a system that is aware of what its competencies are and what tasks it can provide. And hybrid AI has a fundamental role in this, and again, merging data-driven approaches and algorithms with symbolic reasoning and optimization in promoting these 3 levels of awareness, and we will see at least one of them, how we will promote that. Concluding on the project, one of the interesting points is that we don't want to just develop algorithms, but we want to actually integrate these different levels of awareness into one system. And that's why we integrated different contributions in these different levels of awareness into one platform, which is the robot Spot from Boston Dynamics, which you saw in the first slide. Now that I presented the project a little bit, what is actually the role of hybrid AI within the project in Snow? The idea is that as in many systems, we have different functional blocks, different functional steps, even if you want. We go from goal management to self-assessment, planning, execution, situation assessment. And these are all functional blocks that are developed almost in isolation, I would say, and they have their own subsymbolic models that are dedicated to the goal of each block. However, we also have a central knowledge base, which is actually connected to each of these functional blocks, and which has two roles. First of all, It acts as a repository of knowledge and information and makes it so that every functional block essentially speaks the same language. It has the same understanding of the environment and of the mission, and also acts as a repository of new information. So every time that each of these blocks decides to put new information into the knowledge base, this becomes accessible to all other functionalities. This has advantages because it essentially makes it sure that every function is aligned constantly during the life of the robot. And if the knowledge base is also user interpretable, makes it so that the behavior of the robot is also interpretable to a human external observer. Of course, this also requires that the development of these blocks cannot be entirely in isolation, but should be somewhat concurrent because it creates interdependencies. But this is more, I would say, a good push to work that way rather than a disadvantage, I should say. Having talked about the role of hybrid AI, I would like to tell you a little bit about the use case that we have been pursuing in the project as a way to test the capabilities of the system. This use case is a search and assess victim mission done in principle with the Spot robot that I already introduced. The storyline goes a little bit as follows. The idea is that there is a villa from which we received a call because smoke is coming out of this villa, and we suspect that people might be inside this building. A fire brigade is dispatched, and one member of this team is sent into the building, but it does not come out. So the suspicion is that there might be a safety issue, for example, because of gases. Therefore, the idea is instead of sending say, more members of the fire brigade, the idea is to dispatch Spot, which has a specific mission. It should locate the different victims, that is basically the firemen and the family members in the villa, and assess how responsive they are. So which might be an indication that they might need treatment or that we might execute rapidly. In the rest of the presentation, what I will do, essentially, I will show you how within this use case or within this operational context, hybrid AI can be used during goal management, planning, and execution to ensure a more trustworthy system, or at least I will try to convince you of that. Speaking about goal management, as we said before, the goal of Spot is to find people and assess their mental response. One way that we can actually manage our goal using knowledge is by retrieving information on where people are more likely to be placed within the villa and within the rooms of the villa. So assuming I have different people that I'm expecting, Alice, Bob, Cindy, and I believe Dave, knowing where people are more likely to be present at a different time of the day can allow us to create probability distribution for the location of each individual. Of course, this distribution is updated during the search of the mission because people might be found or room might be cleared. But what's important is that if we manage to keep a link between the knowledge of the location of people and these distributions, we might actually be able to leverage logic statements that we will not be able to do if we're only looking at the sub-symbolic, let's say, representation in terms of probability. Let's say, for example, that we have been in the bedroom where we know that Alice and Bob might be here and nobody else, and we found somebody, but we don't know, we are unable to distinguish whether it's Bob or Alice. We know that Bob could also be in the kitchen. And if now we go to the kitchen and we do find Bob there, we recognize that Bob is there, then our knowledge can tell us that there is a high likely chance that the person that we found in the bedroom is Alice. And this is a type of inference which will be more complex to handle if we were only looking at the sub-symbolic representation of this information. Now, enough for goal management. Let's look with the time that we have left to the planning and execution. The planner that we devised to handle this challenge, this mission, is actually a layer planner with 3 different layers. Each of these layer essentially solves the problem at a different level of abstraction. So going from the most abstract mission plan to the very concrete, almost execution level behavior service. What the mission planner does, it solves at least the start of the mission as a series of tasks, which are, as I said already, quite abstract. Each of these tasks is then provided to a task planner, which decomposes the task into individual behaviors and provides it to a behavior service. And the behavior services, what they do, they actually interact with the drivers, that is basically with the actuation of the robot Spot. And of course, we have, from all of these interactions, we can have feedback. What's important here, and you will see in the next slides, is that all of these layers are connected to knowledge. So we don't have, let's say, an individual connection here and there, but there is a consistency in how these layers are connected to our knowledge base. The mission planner is maybe the one that has the, let's say, most concrete connection, because we actually use the information and the models in our knowledge base to generate the model used for planning. I'll just explain myself. In our knowledge base, we actually introduce in the form of templates different models used for planning. For example, we can introduce action templates. So essentially describing in understandable terms what the different capabilities of the robot Spot are. For example, we might have the capability of searching in a room, and this we actually indicate that is connected to the concept of room and the concept of coverage and so on. Of course, in the knowledge base, we also have information about the instances of model and entities. So for example, the instances of the actual rooms that are present in the villa. So if we combine these two things, we can actually generate all the actions that Spot can actually take and all the behavior Spot can actually assume during our mission in a very flexible way. Of course, those, let's say, elements that are a bit too complex to be incorporated in our knowledge base can still be retained, adding to the knowledge base pointers to auxiliary Python code. In this way, literally all that we need to know will be inserted and present in the knowledge base, including those pointers. What we actually generate is a partial observable or non-partial observable Markov decision process, which, if you don't know, it's a very common, very widespread framework for planning, which we can later solve with MCTS-like approach, where MCTS stands for Monte Carlo research. What is very good is that if we do use this knowledge-based representation of our model, we have a lot of freedom because we can control our planning and we are, let's say, on top of our planning, even as the environment changes, for example, because new instances will be added, for example, new rooms, if new rooms are discovered in this villa building. We can also forbid or modify or even allow or introduce actions by modifying essentially the way that these are described in our knowledge base, so the way that we essentially define, even at runtime. One way that, for example, we do use this flexibility is by adding contextualization, which means essentially allowing or forbidding actions depending on the environmental conditions the Spot is finding during the mission itself. So consider, for example, having to look into a room to see if there are any people. What we will do is checking the environmental condition in terms of visibility. So, for example, is there enough light? Is there smoke in the room? And if the visibility is low, then we know that using the camera to look into the room is probably not a good idea. So we can actually forbid this action. Now, enough for the mission planning. If we look at task planning, which has the role, again, of taking the task and decomposing it into smaller behaviors. We already mentioned how at the mission level, these tasks are defined in quite an abstract way. What task planning does is decompose the task into behaviors, as we already mentioned. But in order to do this, it requires some more specific information. I'll give an example. One of the tasks that we might have is to assess if victims in a room are, let's say, responsive or not. One thing that we can do is check in the knowledge base if victims are still present in that room. Because, of course, during planning and after planning, the world might have changed in the meantime. So it might be that people have moved, for example. So if we can confirm the victims are still present into the room, then we can, for example, prioritize. So this is not a choice made at mission level, it's made at task level. Okay, if there are multiple victims, who should I try to assess first? For example, there might be kids or elderlies. Even after having approached victims and identified them, we can have additional steps which might actually write back to the knowledge base, such as confirming identification. So we see how even during, let's say, subsequent planning at task level, we can actually interact with the knowledge base in similar terms what we did during the mission. Finally, going at, let's say, the very last level of planning, basically bordering execution, we have the behavior planning. Now, behavior services are essentially in charge, as I said before, of contacting the drivers which will execute and actuate the actual actions of Spot. You might think that at this level, we might not actually need the interaction with the knowledge base, but we still do for at least one reason. First of all, consider this simple example of exiting via a door. So this is very easy behavior, right? What Spot will do is that it will move in front of the doorway, and then it will move through the doorway. So this is a very simple behavior limit. Now, the point is that we could have provided the behavior service just with the coordinates of the door. But assume that in the meantime, what happened is that the door was closed. We initially thought that the door was open, but at the start of the behavior and during the execution of the behavior, somebody closed the door. Well, if we had just provided information about the position, Spot will just move and possibly bounce with the door, have a collision, or incur in some other unwanted failure. By connecting the behavior server with the knowledge base, we can add additional checks, such as, for example, checking if the door that we requested Spot to move through is still open or not. So what we do, what we have as a result of bringing hybrid AI and hybrid planning to this level is that behaviors are constantly updated with the latest information. And this is immensely important when dealing with open worlds. Now, this concludes essentially my presentation, but I would like to just summarize what I just presented. We have come to the conclusion that hybrid AI and essentially the combination of data-driven, or in any case, sub-symbolic planning and sub-symbolic goal management and execution with symbolic reasoning and optimization is very beneficial for robotic applications and for autonomous systems in general. Because hybrid AI can be used to increase trustworthiness, because we're dealing with a updated, always connected repository of knowledge as information. We can apply the information from the knowledge base transversally, vertically along the planning. So we don't have to consider it only at a specific level, but we can do it at multiple levels. And first of all, I didn't mention this too much, but of course, you can imagine that this level of coordination that we can achieve in planning can also be achieved between the different functionalities, different level of awareness. So we can literally use knowledge base also as a way to connect different functionalities of the system. Well, this really is my conclusion. I want to thank you very much. I think we have some time to take questions, but in case you had questions that were not eventually answered or that you come up later, you can reach me and ask the projects know at the email that you see here in the slide.
Yeah, thank you. Thank you very much, Tommaso. That is, it's always an impressive piece of work. I already knew this project for quite some time, but it's always impressive. What I found equally impressive is that the inclusion of explicit world knowledge comes so naturally in all of the examples that you give. So I was wondering, have there been topics where there was actually a choice between using explicit world models or using a more data-driven approach to solve the same problem? Because as you present it right now, it almost seems always things making to seem to look easy. That is also a way of being brilliant, of course. If it seems easy, it is probably quite complicated, but it seems so straightforward. So have there been struggles where to put in world knowledge or where to put in data-based, data-driven knowledge?
Well, first of all, thank you. Indeed, we are very happy of the current results of the project. Trying to answer your question, I have one example in my mind. There might have been more, I would say, but I was responsible for the planning and partially for the goal management of the project. So that's why also the examples and the topics that I mentioned are the ones that I presented. One element is that what I just mentioned in this slide that I'm currently sharing again was not initially done in the first year of the project. In the first year of the project, we did not have a link between individuals in the villa and their distributions in the villa itself. So we only had distribution of generic people in the villa, which was essentially handled entirely in a sub-symbolic way. We were still happy with the result, but of course, this also gave us some limitations because assume that we are very much interested in finding, for example, Cindy, which is the kid in this simplified example. Well, if you have lost the link, the connection between the individual and the sub-symbolic representation, right, of generic people in the villa, of course, you basically lost information, so you won't really be able to direct search. Whereas in this year, because SNOW is a multi-year program, we would technically be able to do such a connection. So indeed, some things might appear naturally, but it has a lot to do with harmonizing the different functional blocks that I mentioned. So the more these blocks are developed in isolation, the more you might have a tendency of developing less hybrid, but developing strictly in a strict connection with the other functionalities really enables to, in the end, to have, I would say, augmented capabilities. Or at least this is the let's say, the gamble that we are looking into for SNOW.
Okay, that is a very nice and intriguing conclusion that you reached there, that when you are looking in isolated modules, it is usually, well, one approach is probably the one that you follow, but once the system becomes more complex with more interactions, the opportunities to actually deploy hybrid AI are also much bigger. And I think that is a very important conclusion as well, because the most complex systems are also the ones that we think have the highest requirements of being trustworthy. So I think this is a very positive conclusion. The systems that are potentially most hard to make trustworthy are also the ones that can have the highest benefits from using a hybrid approach.
Yes, and I'm not necessarily advocating to always start from, let's say, always putting all the connection already there. Some things happen organically, like it happened for us in SNOW. But indeed, I agree with you. It's the more complex the system, the more hybridization can encourage, basically can help, I should say, in connecting different functionalities, and can also later bring you with a more capable system.
Yeah, yeah. Okay, that's very good to see. Very interesting as well. I do not see questions that have been formulated in the chat window on the stage. So you have left your email address so people can reach out to you if they have some question. And I think then now it is time to move on to the second speaker in this session. Thank you, Tommaso. And then I would now like to welcome to the stage, the virtual stage, Professor Paolo Giudici, who is also a member of the BDVA. That is where we know each other from, and we also know each other from preparing a wonderful project proposal for a Horizon call. And you will present to us what ideas have been developed in this Horizon proposal in order to address challenges with trustworthy AI using hybrid AI.
Yes, indeed. Thank you, Frick. Do you see my screen?
Yeah. Yeah.
Good. So, well, thank you for for inviting me to this session. And indeed, I would start from where Tommaso left us. That is the idea that complex systems are more predictive, but they do need more hybridization because they are less explainable and potentially less trustworthy. This is exactly what we are doing here from a different viewpoint, but we are essentially trying to reach the same conclusion. And so, as Frick was saying, we set up a joint application for Horizon Europe, actually, project that we called TIGER. As you can see here, the acronym is quite complex to translate, in fact, but it stands essentially for Trustworthy AI Getting to the Root of the Problem. So the idea is to develop methods and tools to provide ways to measure trustworthiness, and also methods that are hybrid, that through hybrid AI improve by design that trustworthiness. This is essentially the message that is conveyed through a couple of, let's say, template use cases in finance and the automotive sector that can be made, however, general through a certain toolbox. So I made a quick, overview of the project, but let's now go more in depth. So this is our starting point. Essentially, we are talking about data-driven machine learning models, that are the basis of modern AI. We know that machine learning models have a number of issues that should be improved to, let's say, to boost their implementation in practice. Those problems have to do with, for example, data efficiency, the need that, as machine learning heavily depends on training data, there is clearly an issue about data efficiency, not necessarily. It's not just about the number of data, but the number of data compared to the parameterization of the system. So there is clearly an issue of data efficiency there. There is another issue that concerns predictive accuracy, because very often machine learning model well fit and even overfit the data, and variation and outliers in the data, and then predictive accuracy may be endangered because of this reason. So that is the accuracy aspect. Another issue concerns robustness. Often machine learning models can vary quite much in their output, namely in their predictions. Now think about the self-driving car, for which the prediction of the state of the world is essential, not to make an action. Often this prediction very much depend on specific instances, and the verification of extreme scenarios or particular cases that were not in the model beforehand may turn into a very different prediction. So that is the issue of robustness of the machine learning model that should be improved. So far, we talked about data efficiency, accuracy, robustness. Another issue that we mentioned already is explainability or interpretability. As Tommaso described before, often, especially for very complex models, it's difficult to understand what they're doing in, let's say, human understandable terms, not necessarily in terms of causation, but often, which is typically not possible with machine learning, but sometimes even correlations are hard to draw because the model is heavily complex and depending on many nonlinear and hidden relationships. So we need explainability, that is, translate the output, maybe with the model agnostic methods, trying to understand what are the most relevant features and what they do. Last but not least, there is the issue of fairness, no? That is quite often may arise again with machine learning models, often because there is a sample that is the data that's being used is not fully representative of the the strata of population that are concerned, in terms of gender, in terms of age, in terms of race, for example. This aspect is particularly important for let's say applications in services such as finance, less in the automotive sector, but it is highly relevant in general. A last aspect is uncertainty, that machine learning models typically are non-parametric. They do not have confidence intervals or test of hypothesis, the things that statisticians are used to play with, to give a certainty statement to the result. We predict this result. Instead of saying we predict that probability that the car crashes is 80%, we say we predict that the probability that it crashes is between 60 and 90%, an interval that reflects model uncertainty. This is often neglected by machine learning models. So, having said what is the state of the art, say, of the weaknesses of machine learning models, but also having said, as Tommaso was saying, that they may be highly accurate and predictive, we would like to cure the problems to make them more acceptable and more applicable, especially in the European framework, which is particularly concerned with the idea of an AI that is trustworthy and reliable. So within the project that we set up, we combine a number of cures, of solutions. For example, we implement causal relations and game theoretic mechanisms such as Shapley values to provide explainability. We suggest Bayesian modeling as a key tool to have hybrid AI, so hybrid machine learning that combines data-driven relationships with a priori expert knowledge. And we set up monitor, let's say, a collection of key metrics, key performance, key trustworthiness metrics that can inform us whether the trustworthiness principles are matched by the application, specifically robustness, accuracy, fairness, and explainability. So within the project that we wrote, that whose main ideas I summarized before, there is a consortium composed of universities, research centers, and also industries. Particularly, the coordinator is DFKI from Germany, together with the TNO and the University of Pavia, that is Frick and me, are among the key players. And then we have University of Amsterdam and the Technical University of Eindhoven among the universities. And then we have in the specific companies, such as Valeo for the automotive sector, and Real Rate and Klarna for the financial or better financial technology sector, fintech. And last, we have engineering that provides the IT infrastructure that implements what we developed, let's say, in the previous part. So as I said, what we develop, what we plan to develop, of course, if the project is successful, is let's say, a combined strategy that starts from step one, individuation of trustworthy AI metrics, key performance metrics. Now, for in general, they can be applied as test bed for any AI application that involve the use of data. That is KPIs of accuracy, robustness, explainability, and fairness, and data efficiency. So 5. That's the first thing. Second, we develop a hybrid AI methods that can improve in terms of the previous 5 principles over classic machine learning methods. Third, we implement the previous 2 into a full IT DevOps implementation, and we do this jointly into key use cases, that is finance and automotive. This is essentially the structure. In fact, the IT infrastructure is called a Boxology framework. So what are the main results that we believe will be reached? As I said a number of times, a way to measure trustworthiness, which you can also frame as a way to measure ethics of AI, no? Because we often talk about the ethicality of AI. That is, there are a number of papers, publications, and discussions on that, but not so much in terms of measuring the ethics or the ethicality of AI. So that is what we provide. And then we contribute to the 2 specific use cases, particularly in the automotive sector, in which the idea is to predict the behavior of the surrounding environment, no? The environment that surrounds a self-driving car. You should understand not only what the other cars are doing, but what pedestrians, bicycles, scooters, whatever you want, are doing. And this is a very challenging task, highly multidimensional. Whereas in the field of finance, we have certainly much less data, but the challenge there is that the sector is highly regulated. So in finance, the application we will deal with is credit scoring, you know, what is used to assign a credit, you know, what a bank or a fintech or whatever financial service calculates before deciding whether to give a credit or not, and before deciding what type of interest rate to price on that loan. And clearly, the data that is used is about the characteristics of the applicant. No? If the applicant is an individual, it would be personal characteristics, but also transactions in the bank account and so on. If the applicant is a company, you also want to look at financial performance, balance sheets, and so on. In both cases, the data is not as much as in the automotive, less multidimensional, but the sector is highly regulated because any bank or fintech is supervised by European Central Bank and by authorities, financial authorities. So any model that is in place should be validated by those authorities. So for the time being, it's very difficult for a machine learning model to be validated by authorities because they are black box. So here they need to develop explainability is key for the very existence of the AI application in finance. Without the reaching of trustworthiness, it is almost impossible to put through financial services based on AI. And as I said, there is a toolkit that implement all of this in an open source code repository. So that is the idea. Again, on the use cases, in fact, this is something I said already. for a highly automatic driving, the case that I mentioned, the automotive sector, we are still in some kind of disillusion. No? Seems that we are at least 30 years away before the implementation of this, especially on local streets, no? Not on highways, where it's somehow easier to do this. There is a research currently on the perception of the behaviors, but the challenge is to create reliable predictions of human behavior. That is very difficult to do because it is highly interactive. It's a game theoretic thing. So these are huge. The main challenges here are data efficiency, robustness, and accuracy or generalizability. And Tiger would fill this gap, building models that include contextual information, expert knowledge, and thereby provide through hybrid AI a better solution. In the financial case, as I said before, data is a lower dimension, but the models must be validated by the authorities. So here the challenge is not much about data efficiency, but rather about transparency and explainability. And here we also are going to improve on those. Though the two use cases that I mentioned are to somehow extreme situations. No? In one case, there is the automotive sector. There is an issue of data efficiency because the predictions are very hard to make. In the other case, there is data is enough, but there is an issue of explainability. So somehow there are two kind of extreme scenarios, and you can think of others lying in between, like the health sector, for example, is characterized by, let's say, more data than the financial, in particularly heterogeneous source of data, but it is also regulated, but not as much as the financial field. So it's somehow close to finance, but not for certain aspects, and close to automotive for others. And you can think of many other use cases that can feel in between. So this is what I wanted to say, but I very welcome discussion as these, I believe, are very hot topics on which there is not much research. Actually, there's very little research and development. So it will be very important in the European context to work on this field. Thank you.
Thank you, Paolo, for this very good introduction into what are future plans around hybrid AI. It was Tommaso who presented current results, but you are looking into the future, what is going to happen. There is a potential audience of 225 people who are registered for the meeting. You are still sharing your screen. Oh, not anymore. Who registered for this session. So it is a big audience. And I can imagine that maybe some people are shy in such a large audience, but I do not yet see questions in the chat window. If you have questions, please put them there and I will forward them to the speakers. While you are doing so, I had one question for you, Paolo, because we are now discussing hybrid AI as a means to make AI more trustworthy. And I noticed that while Tommaso was addressing it in a way to make the AI better, I can imagine that especially in the financial sector, but maybe also in the automotive sector, which are regulated domains, you could also use world knowledge models to restrict the behavior of the system. So it is a kind of a normative envelope that you are imposing on your system. Hard rules like You can do anything within the limits of these rules, but you shall not operate out of bounds. Do you expect that this will become an important part of hybrid AI, or do you think that using world knowledge will be mainly used to improve the existing operation of the accuracy of AI systems?
Yes.
What is your opinion about these two uses?
That is a very good and difficult question, Frick. Thanks for asking. Indeed, there are two ways in which the knowledge can be used, no? Using the language of, let's say, graphical models, or let's say causal, if you wish, the probabilistic expert systems that were in place in the 90s, to which we are somehow going back. There are two ways to implement this knowledge. One is to improve AI, no? And that is, let's say, for a fixed structure of causations or of correlation, fixed links between the different variables or nodes in the network. So for a fixed relation, we can learn from data better with hybrid AI, with expert knowledge, which we can encode into Bayesian a priori structures, for example. But there is a second way that is exactly what you mentioned, to enforce rules into the structure, no? That is to use the data to learn between different structures and work with the structure that is most likely, or with the structure that is most supported a priori. Okay, this is a way to, as you said, to embed the rules, not just to improve AI, the machine learning, but to force machine learning within a certain subspace. So it can do both. I hope I answered.
Yeah.
May I comment on this, Freek?
Yes, please.
It's a very interesting discussion, and I totally agree with Paolo. Although I would like to add that the concept can also be flipped on its head up to a certain point. What I mean is that it has also very often been a prerogative of, let's say, sub-symbolic interpretation of rules to be implemented in a system where they become, if we think of behavior, they become very hard boundaries, but it is which the system cannot, has to operate within, right? That and the tendency normally of designers is to make these boundaries sometimes taking a pessimistic approach, more restrictive than they should actually be. But it is known that in certain situations, sometimes one has to prioritize over these boundaries, right? And hybrid AI can actually, we have seen it actually also at TNO, I believe, in some research done in the Helmond unit, where hybrid AI can actually sometimes be used to prioritize between boundaries. For example, even in the automotive domain, when one might have the, let's say, the temptation to add every individual code of conduct or rule of the road as a hard boundary, when one realizes that sometimes some boundaries, some rules have to be broken. And then the question is, perhaps the insight that I think people are discovering is that maybe, let's say, hybrid AI can lead to a good prioritization between which boundaries to break. So it's interesting how there is not a clear-cut answer, but you can really sometimes also even flip the question on its head at a certain point.
Yeah. That's a very interesting observation, because people have already noted that if you would convert law or regulations into computer executable code, there will inevitably be contradictory situations, and you would definitely need prioritization mechanisms to find your way out of that. Yeah. There is a question being formulated in from the audience from Norbert Jartrog. Very good to have you on board again, Norbert. I know your interest in this area, and you have formulated a very interesting question, and it is very well formulated. So I will read it literally. Norbert is writing, I understand that your approach to hybrid intelligence is about how to enrich data-driven AI by epistemic knowledge generation. Do you consider the other way around in your thinking as well? And if so, how? Because this would be to support knowledge generation by targeted reflective data reasoning, thus more sustainable, while innovative intelligence can be reached by combining human intelligence with algorithmic intelligence. For instance, to reduce the retarding effect of human loss aversion in decision making. So what Norbert is saying, could it be the case that you could also use data-driven AI and insights that you get from it to also improve the human understanding of the world? So yeah, maybe starting with you, Tommaso, what would be your thoughts on that, to use hybrid AI the other way around, so to speak?
I have to be too honest in saying that indeed, in my presentation, we trickled down from, let's say, symbolically charged or semantically charged concepts, and we try to apply them into the execution of sub-symbolic models, like I hope was clear from my presentation. The question, if I try to summarize it, is basically, can you actually also use data to generate concepts in a sense? I think actually quite some work, I believe Paolo also mentioned, that has been done in causality reasoning, right? When we basically try to see if the data can explain, it can not only be used to predict the model, which again, it's maybe very rich, but not semantically rich. Instead can be used to explain why certain events have happened. I think I mentioned before how in our projects as Snow we can think about how environmental context can affect the actions that can be performed by the robot. A part, although on which I'm not, let's say, the most capable person to speak of. One of the functionalities that I mentioned was self-assessment, and part of it is also causality reasoning, where some of my colleagues are trying to explore basically the incoming performance of some actions performed by the robot and try to justify, for example, why a very low performance is achieved. So if you are in a room, as I said before, and you use your camera and you expect a certain performance, but this performance is very low, they have been studying causality assessments, trying to basically identify, okay, what is wrong with this room? Why does my camera not work correctly? And as I said, I'm not, let's say, an expert enough to go into this in detail, but indeed, I think such approaches do exist. But maybe they are a bit more recent, perhaps. Maybe they're not as immediate.
Yeah. Okay. Yeah. So then we're also looking into the future again, and maybe it could be a potential topic in the Tiger project. Paolo, what would be your idea for that?
I think so, and I think it fits very well with the idea of explainability as well, no? Because in the end, explainability or interpretability mean exactly what was in the well, closely to what was in the question. That is, converting the data-driven conclusions into something that is explainable, no? Into some potential causations, the most plausible causations based on the data. That is what explainability is doing, no? If you have 1,000 possible explanatory variables of a phenomena, explainable AI tell you which are the ones that explain the largest part of the variation in the response, no? Essentially, so it is a way to, in fact, to infer what you were asking from the data, okay? And of course, here comes, clearly my vision as a statistician. I didn't say in the beginning that I'm a professor of statistics, so this soul sometime come to me, and in this case, it tells me that we also need to test. Once we identify which are the most explainable variables, we should implement a statistical test to say why we use 8 of them and not 9 and not 10 or not 11. Now that is quite crucial. It is the role of statistics there.
Yeah. Okay. So you definitely see room for this approach, and it is already being contemplated indeed for topics like causality detection. Yeah. And I think that is a very interesting topic to arrive at, because then you are actually arriving at something that we also call co-learning. That means the machine learns from data that is provided by the humans, but the other way around, the human end user also learns from the machine. And if all is going well, they are entering a virtuous circle where the machine becomes better at understanding the data that is provided by the human, but also the other way around, that human behavior improves, becomes better, more well informed, because it is supported by machine intelligence.
Yeah, this, if I may, Frick, this you made an extremely important point. That is the point of endogeneity, because especially in human behaviors, the data is also generated by the humans. So we build models based on data that can suggest causalities, but the data itself is generated by us. So there's a little bit of endogeneity here, no? It's not a natural experiment in which data is generated objectively from the outside world and we observe the consequences. Here, both the data and the hypothesis, let's say, are generated by humans. So that is a challenge.
Yeah. Norbert is also commenting in the chat that he's saying that research into the world climate is also an example of this, where you start with the data reasoning, and by looking at it, and this will lead you to formulate hypotheses just because relations have been identified by a data-driven approach. Yeah,
yes, that is another important, very important example.
Yeah.
Because there, indeed, you have to build scenarios in the climate change, for example, topic. Data do not exist. Really, we can build probabilistic scenarios for the future, which again are generated by us.
Yeah, definitely. I have not seen additional questions coming up in the chat, and as I said at the beginning of this session, Dr. Christian Müller of DFKI had not yet arrived, and something has gone wrong because he is not joining the session. So probably something has been working out differently than anticipated. So that means that it has been these two contributions, but still I'm quite happy with it, because the first contribution showed some results in actually applying hybrid AI. And then the second presentation was really looking forward into what you could do with hybrid AI in a much more methodological way, and also in some different domains. So I think that nicely puts between brackets the topic of hybrid AI. Where are we now, and what are the plans to continue from here? And we had a very brief discussion right now on the potential meaning and importance of hybrid AI for better human-machine teaming in the future. That sounded a little bit like a conclusion. I would like to invite you both to also add, maybe one or two afterthoughts in a concluding way, looking back on what we've discussed, and also looking at the questions that were asked. What would be your conclusion when we talk about the topic of hybrid AI in relation to trustworthy AI?
Should I?
Go on, Thomas. Yeah.
I would like to finish with a big why statement, but I will just maybe repeat what I already said previously. I really believe that, and I think it's evident that hybrid AI is going to arise organically when dealing with complex systems, and it is bound to increase trustworthiness due to a better understanding and a more relatable sharing of knowledge and information. Of course, I indicated at the start of my presentation what are the challenges, what we think at least in TNO that are the challenges, and moving away from, let's say, the current AI and moving towards more future AI with more complex systems, more diverse spheres of application. We are bound, I believe, to engage more and more with hybrid AI and push also the limit of what can be done and what constitutes hybrid AI further to enable better and better capabilities.
Okay, that is a very positively formulated conclusion. Really looking forward. Paolo, what would be your take on this?
Yes, my take is that we do need, I mean, it's clear that hybrid AI can bring important contributions and value, not only to improve machine learning and AI, but also to build them in a way that is consistent with our thoughts and beliefs. No? But I believe that to achieve this goal, an important effort should be undertaken in terms of standardization, particularly as far as trustworthy indicators are concerned. Because often we talk about principles, no? Fairness, and anti-discrimination, robustness, and so on. But we have not yet a common standard to measure them, and we do not have thresholds, for example, that say, above this number is fair, below that number is not fair. So this, I believe, is something that should be done in the near future, particularly in Europe, to achieve the goal of improving the AI.
Yeah. And I think the key trustworthiness indicators that are proposed could form a basis for this. So that's a very good, that was a very good idea. And I really hope that we will be able to elaborate on them. Yeah. Okay. Well, I think that is very good to conclude with, that there's really a very good future for the application of hybrid AI, and it plays a number of roles, and it can definitely play a very good role in the context of trustworthiness, and that is a specific way that the European Commission really likes to pay a lot of attention to. So the topic is here to stay, and I think that in future editions of the EBDVF, we will be able to report on any progress made in this field, because I think it will only grow bigger. I would like to thank the two speakers for their contributions. I would like the audience for staying with us at the end of this day, and your heads must already be full with lots of information. Maybe I see a number of you again in sessions later this week, and otherwise we will see each other in other conferences, hybrid conferences, physical conferences, whatever. So thanks again. And I think this concludes our session on the role of hybrid AI in relation to trustworthy AI. Thanks again, and see you later.
Thank you.
Okay. Bye-bye.